Right, so we're live right now.
Just consider 10 years ago how much money it would cost to do exactly what you're doing right now, broadcasting potentially live to the world.
Yeah, and then the software that allows it to happen with multiple camera angles and all that is kind of really impressive.
The zero cost factor of what we can do with very little money.
It's impressive. It really is. So, whilst we get some bums on seats, because obviously we've done this kind of without a script, I will set up a couple of things so that I can... just bear with me while I get... So I don't need the audio input, I need a visual, I need a screen.
No, we're not going to bear with you. We're going to whip you into a frenzy.
A window, oh, really? Now, Skype.exe. Is that the one that I
Poke
want?
fun at you, tell you how stupid you are for not knowing how to control. You're a bad MC.
Well, if you either of you two want to fire up your webcam so that you can be seen.
I need to get a webcam. I don't actually own one.
Angel, do you
That's pretty poor, isn't it?
want to fire up your webcam?
No.
Okay.
Is it not on?
It is.
Okay.
Now the question I've got to try and do is get this to the front.
And what did God say?
Let there be light. You.
There was, and he was happy.
Shut up, you. Right, I'm trying to work out how I can get this flipping window capture on because it doesn't appear to be doing it. Doesn't matter. I can leave it as we are now. What was that dodgy music?
That was one of my monitors turning on.
Okay. Oh, right, okay. I thought you were getting jiggy with us for a minute then.
Oh yes, my vibrator has a sound pattern depending on what setting I set it at.
Right, so what I need to do is I need to go and pop out the chat, don't I, so I can see how many people there are in. So hang on a sec. Alright, so my channel. And then that. Right, so we have 12 in chat right now. Oh, let's get rid of that sound. Yes, we have 12. Karen B's in. Everybody wants to talk about the Eclipse today. Yes. Colossophonium, you still haven't given me a planisphere model and maker, fool. So you give up. Where is Octan? Is it south of Santiago or Chile? Colossophonium? If you carry on with this, mate, you know exactly where I'm at with this one. The onus is on you to prove that your assertion is true. I'm calling bullshit on your assertion. So you've got to prove that yours is true. That's before I even deal with yours in any sense. So Colossophonium, if you want to stay in this chat, drop it until you produce evidence, because I am not going to allow you to troll me. Okay? Good morning, Maika's place. Or evening, if you will. Ranty's in Maika's place. Maggie M is in. Marie is in. Let's see. I need to pop this chat out so I can keep up with it. Right, we're all talking about the Eclipse. But we've got a different slant on the Eclipse, one that we haven't come across before. On the chat now, I've got Angel and I've got Ranty, and we're basically chatting about what should we see in certain circumstances. And my position is from...
I thought we were talking about where to send the videos.
Well, we're talking about what should we see, because it appears that if you're in the north of America, you're going to see a full eclipse. But for me, I want to know what will we see in England, because I want the ball earthers to tell me accurately whether or not we'll see any of it, some of it, and if so, how much. Because if the sun and the moon are really that far away, i.e. 93 million miles for the sun and 245,000 miles for the moon, then we're only 3,000 miles away from North America. So that kind of makes the amount of parallax from the moon at 240,000 miles away not actually that much. We still should see some of the eclipse. The question is, how much do we see? And I want the ball earthers to commit to how much we should see. Because what I'm going to do, I guess you've all seen the photograph that guy took, Stephen Cheatley, from Winter Hill of Blackpool Tower. And in the background there was the Isle of Man mountains, and what that did was bring in a whole debate of perspective and stuff like that. But from that same position, that's where we're going to see the eclipse. We'll see the eclipse in the far background over Isle of Man. Now, if we're at Winter Hill, we'll somewhat negate the effects of the mountains over Isle of Man. So we should see the sun setting. But if the sun and the moon are really as far away as what they say, we still should see some of the eclipse, because 250,000 miles away is a lot when we're only 3,000 miles away from the eclipse itself, from the actual shadow. So my point on it is, I want the ball earthers to predict what the UK should see with some precision about their ball model, because apparently, according to Cara, their model is so intuitive that it's so easy to predict, and it doesn't even need explanation. But nobody can work out whether or not this shadow, whether there should be a shadow or not, and if so, whether the shadow should be going one way or the other. And on a really highly intuitive model, I don't think it's an acceptable position for the ball earthers. And I believe that they should be able to apply this highly intuitive model and give us a prediction of what we should see with accuracy. Because I think that from the moon at 240,000 miles away, I think that the UK should see some of it. It won't be a full eclipse, but it should be some of it. And when you consider what Thrive and Survivor said, and Sun and Moon Group, they both predict that the object that's casting the shadow, in this case the moon, the shadow from that object cannot be any smaller than what the object is that's casting the shadow. So basically,
Exactly.
if it's a pinprick on the map, the way they show us according to NASA, then that's really how small the moon is. But if the moon's as big as it looks, and it's as close as people think it might be on some kind of flat Earth model, then the size of the shadow will be massive, and we will all see a much bigger eclipse. More people will see more of the eclipse than ever gave credit for. So the question is, well, what can people see? But we've got a bit of a skew on it, because we can see from the UK the same sun that the Americans can see, because it's setting on our horizon to the west. So if we're looking due west and we see the sun setting at the same time that them guys are seeing it actually eclipse, on their model we should see some of the eclipse. The only difference would be a little bit of parallax. But on the flat Earth model, if the sun and the moon are really close, then we wouldn't see any of it, because the parallax would be huge and we wouldn't see any eclipse whatsoever, assuming that we can see the sun. So I want the ball earthers to, if their model is true, they should be able to predict accurately how much we will see. And that's really what I want them to do, tell us how much we'll see, because I don't think we'll see any of it at all, because I think that the sun and moon are close. Ranty lives near me. Ranty's thinking of doing it from Blackpool Tower. Angel's in North America. He'll see pretty much most of it, but he's outside this path of totality that they tell us about. But I think that he's going to see a total eclipse. Angel's not sure. Angel thinks maybe you can, maybe you're not.
I'll see what I'll see.
But their model's supposed to be so intuitive that we should be able to do this with precision based on what they tell us is a very intuitive model. It's so intuitive. And it doesn't appear to be the case, because if it was intuitive, then people that are in on the fence, like me, and people that don't know, that are looking to see whether things work out, there wouldn't be this disparity. You wouldn't get Antonio saying that it can't happen. You wouldn't get Sun and Moon Group saying it can't happen. You wouldn't get Sliced Barcane saying, oh yeah, it can, you're just being thick. You wouldn't get other people.
What do you think? Sorry, can I just interrupt, Anthony?
Yeah.
Yeah. I actually think that what is going to happen is exactly as NASA has predicted, is that it's going to be a very small 70-mile wide shadow that's cast on the Earth, and they have used their model that they've now put out to show that this is the model that works. But this model that they've put out is contrary to every other model and every other belief system into the rays of the sun that has gone before. So one of them has to be wrong. But they're using this model they put out now as a way of explaining away the fact that the sun is in fact actually a lot nearer. So I do actually think that we are actually going to see what they predicted, because that's going to be the truth. But they are trying to say that it's the sun's rays are now converging at a different angle, as opposed to a 90-degree angle, which is what they've always said from day one.
Well,
so which model do we take to believe?
Well, I don't know. I think I agree with Karen's comment in chat. She says everyone who can see it needs to film it from wherever they are, and then we can compare it all afterwards. Speculating does no good. Maybe, but what does do good is speculating in terms of, well, if other people can see it, the issue is not whether or not we can see it. The issue is whether or not we don't see it, because I don't think on the heliocentric model we should all see an element of eclipse. Now, you may only get, if you're on a shallow angle like we are, you may only get 10 or 20% of it. But if you're on a prominent angle like North America is, you're going to see a lot of it. But that's like almost all of Europe, all of Western Europe. So if the reality is that we see it from Europe, then that supports the heliocentric model. But if we don't see any evidence of an eclipse from Europe, whilst America's getting the total eclipse, that doesn't support heliocentric model, because we should see it. I don't think there's any debate over whether or not we should see it. The only debate is how much we should see. But the consensus is that on the heliocentric model, Europe should see some of it, somewhere between 10 and 25%. So their predictable model would be that you can see some of it. And I agree, you should see some of it. But I don't think we will in real world. I think in real world, when we do the observation, I don't think we'll see any of it, because the sun and the moon are close, and the amount of parallax when the sun and moon are close is huge, meaning that we'll not see nothing. So this is what I'm...
We should. That should be the case. But the laws of light and what NASA have put out and science has put out is that the light travels at a 90-degree angle, and it heads off and it's in a straight line. That's it. And every model that you see, when the sun's rays are hitting the Earth, they're all hitting them at a 90-degree angle. So if the moon is blocking out all those light rays, it should be blocking out over 2,000 miles of light rays. So the eclipse should be 2,000 miles.
Yeah. But this is where
what should happen if their model is correct.
This is where it gets interesting from my point of view, because I've got quite a few cameras and quite a few lenses. So what I'm going to do is I'm going to take 3 cameras on 3 tripods with 3 different lenses, and they're all going to have slightly different setups. Because the argument, there's an issue with whether or not to use a solar filter. Just hang on while this bike goes past, because this is going to be loud. Just one sec. Okay, so basically the issue is, from England, do we use a solar filter or not? Because if we don't use a solar filter, they're going to say you've got to use a solar filter. But if you use a solar filter, because the angle of rays is so minute, so acute, or so shallow rather, we're going to be getting really dilute rays. So you may actually miss it completely. If you put a solar filter on, it might actually block out that much of the light that you see nothing, which then would be a waste. So I'm not sure whether we should be using a filter or not. But if we do use a filter, the chances are we'll miss it, because I think it'd be too dark for the light that we're actually getting at sunset, which would be minimal. But maybe somebody can suggest what the position should be. But in any event, I'm going to set my P900 up.
Well, I'd like to suggest that since you're getting real-time photos, you don't have to go and have them develop that photo track.
No.
That you can try, experiment.
Yeah.
Or toggle back and forth between them as you take your pictures.
Sure. But what we might be able to do, or what I'm thinking that I might be able to do, Mickey, shut up. I'm thinking that we could... Oi! Enough. Moo. Thank you. Stop it. Stop. So what? Right. This is what I'm going to do. I'm going to take 3 cameras on 3 tripods. One of them's going to be the P900 at full zoom. Another one's going to be the D500 with the solar filter on it and a 400mm lens. I'm going to take a D300 with another similar zoom on it, with a super zoom on it, because that's going to work as well, like me 500mm one, me 5000mm one, because that'll work. And then I'll use the D3200 to record all three thingies taking pictures all at the same time, so that there won't be anything suggesting like soundly where there's some kind of like Mickey Mouse bending of light kind of stuff. Because what that'll do is they'll all be consistent, but they'll have significant differences, and I'll be able to talk through it as long as I get them set up initially in the first place, it'll work. And we'll get 3 type of observations from the same vantage point of the same thing, but in different circumstances, and that'll work. I just need to know how much should the UK expect to see of the eclipse, because I think it's going to be about 20-25%. Because
it would be interesting to get Geo Streeter on.
He's in chat.
Because he seems to suggest that the totality of the eclipse will only be like 70 miles.
Geo, do you want to?
It'll be interesting to see what he has to say.
Geo, do you want to load up Skype, and I'll add you to the call on Skype, because we're doing this through Skype. I'll send you. I'll join you, Geo, if you want to add. Just come on and you can talk. Add people to this call. Geo, where are you? Oh no, you aren't Alex, aren't you?
How many does Skype let you have now?
I don't know.
They keep changing stuff.
Right, let me stop sharing. By the way, Angel, we can't see you. It's just me at the minute, but I think Gio's on his way in.
Fine. I'm not worried about it.
Life of Riley, can you give me a few minutes? Sure. Well, I've added you to the call, Geo, so you sort yourself out. Because maybe, I mean, the reality should be we should see some of it. But I don't know how much we should see. And Geo was the one that, well, Hillel Finder reckons that we'll see 10% of it. I've got him quoting 10%. But the interesting thing is, we should see it. Whether we see 10% or 20% or 25% isn't really the issue. The issue is we should see it. But in the real world, I don't think we're going to see any of it, because I think the parallax if the sun and the moon are close, the parallax will be that prominent that we should not see any of it at all, and it would be as though nothing had happened in the first place. So the heliocentric position is we should see something. In my position on the Earth, my position is I don't believe we'll see any of it, and I think that this is going to be basically if the sun and the moon are far away, then the onus is on the heliocentric model to see evidence that we could see it from our angle. And I'm going to have 3 cameras trying to do it. Because if you only have the one camera, there's going to be there'll be some excuse about, well, you didn't have the right setting, or you didn't use a solar filter, or you used a solar filter but you shouldn't have done. So it's trying to kill all, catch all, and see where we end up.
So what do you think about a place that we can upload all our videos to?
There's not going to be one though, is there? We're going to have to collate all the information.
There should be. I think somebody should stand out. Somebody from the flat Earth.
Volunteer Antonio.
Antonio's super H, yeah.
Well,
he does seem to be the one who really likes to sit there and play with the numbers and work the system.
Yeah, I mean, there's the Sun and Moon group as well. They're playing around with stuff as well, because they want to make certain things happen too, which is cool. I mean, I don't really care. I just want to see what happens. What should be expected.
Yeah, but you should care, really, because if everybody uploads the videos and everybody triangulates this stuff, we can literally nail this stuff. We can nail it down to mathematics, and we can nail everything down.
The cool thing is, as long as we do video record it and we do archive it, then
yes,
we always have it.
All the flat Earths, even if you only use an iPhone.
Yeah.
And even if you have just a YouTube channel, you've never uploaded a video before, just get your iPhone out, video the sun from where you are with the location, and upload it, and then you can link Antonio or whoever or Sun and Moon Group to it, and they will have that as a reference for your own evidence, and they can triangulate everything and put everything together in a model, and they will be able to use this evidence. The more people that do this, the more evidence we're going to have. If there's only 1 or 2 people doing it, it's pointless. But if we've got 1,000 people doing it, then we have a good vantage point to make an argument from.
Alex should be coming in a sec. We'll hear what he's got to say, because Hillel's committed to 10%. I think on the Helio model it'll be nearer to 20%. But let's just see what Alex thinks, because it's only really a good thing. It's not really a bad thing. And I'm just.
Who has echo? Is it me?
I don't know. Have I got 2 mics on? Hang on. Let me have a look. Which is my camera that's working here? Is it that one? Or is it that one? It's that one there, isn't it? Right, so Brio. So if I bring that one over here. and then move that over. So this is right. So now we're seeing the Skype chat. So Angel, we can see you. We can see me. If Alex joins us, then we're going to be seeing the lot. Let me just check. No, I don't see any other. Mic, desktop audio. Ah, audio input. Yeah, that one. Right. I don't think there's any echoing now. So ain't just one of you say something. Just say hello.
Hello.
La
Yeah.
la 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 la.
Yeah, that's working. So essentially, we just need what's his face in now. Alex.
Alex.
Yeah, and he said give us 5 minutes. Oh, he's here.
Can you guys hear me?
Yeah.
I've been here for like 2 seconds or so.
Cool.
Hi.
How much should we see in England, Alex, of this eclipse while North America's getting it?
First of all, not the entire continent of North America is getting it. The strip with the zone of totality is like 50 miles or so wide. So if you're talking about the totality zone, then 99 or so percent of North America won't see it.
Have you seen?
Did you say 15 miles? Did you say 15 miles totality?
No, I said 50. I said 50.
50, okay.
Yes.
Have
I
you
don't know the exact numbers, but that's quite a usual value.
have you seen the two videos by Thrive and Survive and the Sun and Moon group that both say that the smallest size that the moon's shadow should cast is the same size as the moon itself? It shouldn't get any smaller. In other words, they've ruled out the umbra and the penumbra scenario and said that the absolute minimum size of the shadow cast by the moon is its own diameter.
Yes, and he's right in the sense that the penumbra is always bigger than the moon. The umbra, however, isn't.
Yeah, but he's saying that there wouldn't be any shadow cast that's anything smaller than the size of the moon. In other words, the shadow on the Earth should be the size of the diameter of the moon and no bigger, or no smaller.
No, that's false. Geometrically, that's definitely false. And
Well,
I can show you.
Well, you got Thrive and Survive has done a video saying that, and so Sun and Moon Group, and I tend to agree with them. It makes sense that you wouldn't get a shadow smaller because they just.
Again, it depends how you define a shadow. Because if you define a shadow as being the part behind the object where all the light is blocked, then yes, you're right. But if you define a shadow as the part where part of the light is blocked, then you're wrong.
Okay.
We can do it geometrically. It's quite easy. You want me to do it?
No, it's cool because we're on Skype, aren't we? So we'd have to share desktops.
Yeah, I can share my desktop.
Okay, you go on then. You can share your desktop if you want then.
Yeah, just give me a second. I have to close everything else.
Make sure you do system sounds as well if you're gonna put a video in.
Yeah, I'm on my laptop. That's the problem. It's not. First of all, I don't have good bandwidth, so if you see that the video is unsharp or anything, just tell me.
Sure.
And second of all, the hardware is really crap. I need to update it as soon as possible.
They're saying that the guests sound very echoey, but I think it's because my own microphone's picking up my speakers, which I've just turned it down so that it doesn't do that. Hopefully, so their echo should be curtailed.
To be honest, to me, you sound quite crappy as well. In the Google Hangouts, usually your audio quality was way better.
Skyfly Bride says, you will need a solar filter and you need to take photos from 1956 to 2002. You will see a very small chunk of the sun missing like the Apple symbol, but it will be at the bottom. Yeah, I agree. It's probably at the... Yeah, it's going to be on an angle at the bottom, I agree. But I believe it's longer than that. I believe it's more than 4 minutes. It's nearer to half an hour.
So, can you guys see my desktop?
Yeah. So make sure you get rid of any porn.
Yeah, usually my porn is closed, and it's not on this computer. What do you think I need 3 monitors for?
Yeah.
Different camera angles.
Yeah, I think we probably will need a solar filter to see the eclipse, because although the sun will be light rays, we need to see the moon on the sun.
You won't be able to see the moon itself. Maybe some of the craters on the side, but you would need a massive magnification. So, can you see that I have paint open?
Sure.
Alright. So, let's do this again. Sun. Earth. Obviously not to scale. Right now, at least. And... Moon.
So basically, if I'm stood on this winter hill, this queues up nicely for a particular sound file.
Alright, so let's draw some lines again.
I just realised you couldn't hear that, could you? So what I needed to do was share my sounds. Actually, no, because it's picking up desktop audio. Yeah, that would. Did anybody hear that Beatles song then?
Yes,
A little bit.
Let me play it again and just see if it's coming through on the mixer.
Alright. Can you see my drawing?
Hang on a minute.
He's too interested in playing with sounds.
Seems the world's spinning round. Anyway, so I would be the fool on the hill. So what is it you're showing here, Alex? Oh yeah, the umbra and the penumbra.
Yes. So in the model I showed now, this would be a ring-shaped solar eclipse, because the black part is the umbra and the gray part is the penumbra.
Yeah.
As you can see, the penumbra is never smaller than the moon itself, right?
Yeah.
But the umbra is always smaller than the moon. So for a total eclipse to occur...
Yeah, but hang on. Do you agree, though, that is contradicting what Thrive and Survive and Sun and Moon Group have said? Because they've said that the size of the umbra can never be smaller than the size of the object that's casting it.
Yes, and they're wrong about it.
So in that...
under the condition that the sun is bigger than the moon, then yes.
See...
I would argue that the umbra on this on the diagram that you've done now is
Yeah.
not to scale in any way, shape, or form.
It doesn't.
That umbra should be almost all of that black part of the umbra must be casting its light up on the Earth from the distances that are provided, 93 million miles, 245,000 miles.
We can do it to scale if you want.
To scale, yes, please.
Yes.
It won't make any difference though,
More
because
complicated.
it won't make any difference though, because you weren't showing the light of the sun that was illumining the umbra. Because in that image that you've got there, the lighter grey.
Yes. In this image, indeed, I am. So you see that this light ray here.
Yeah.
This is from the bottom part of the sun, obviously. So.
Well, just do us a favour, Alex. Just put a blue line in from the bottom of the sun.
Wait, just give me a second. I'll explain it. So, do you agree that if we had a light ray, I'm going for green this time. If we had a light ray here, then this part of the sun can be seen from the umbra. Do you
We
agree?
can basically say that it's the sun and the moon. It's basically what 460 times or something.
Just hang on a sec.
Please,
That line.
Please answer my question first.
That line that you've just put in there, that would be total sunlight, and it wouldn't have a shadow at all.
Yes.
Oh, let me work this out.
Yes. Yes, there would be a shadow, because from this position here, where I draw the end of the line, you couldn't see the bottom part of the sun. And let's say you're standing here, right there.
Yeah, but you're still getting
to see this part of the sun at all.
Yeah, but
Only this part.
you're getting direct sunlight, and a lot of it.
Yes, you are indeed, but you're not getting the entire sunlight, and that's how a partial shadow is defined. That's how the penumbra is defined. The closer you get to the totality zone or the umbra, the less of the sun you will see. As I can show you again, let's say you are. First of all, I'm going to zoom in a little. Does it fit? Yes, it fits. All right. So let's say you're standing right there. Can you see the little X that I made?
Yeah.
Right there?
Yeah.
Right, so let's draw some lines again. in. So, right here, at this position, you would be able to see about 2/3 of the sun, but not this part over here.
Yeah, but the fact that you're getting sunlight at all means that you're not going to be in shade.
Yes, you are. Well, again, it depends on how you define shade, because when you are in a partial solar eclipse, you obviously see a part of the sun. Do you agree?
Yeah, you see most of the sun, right?
Right. Yeah, you will see in England about, I think it's more than 85% of it.
Okay.
So, yeah, you will see the most part of the sun. But when you take a look at the sun, oh, that was not my intent. What it will look like for you is, from our vantage point, they are more or less identical. So I think it's fair to say that you are going to see about...
Yeah. Yeah, I get what you're trying to show.
Yeah, alright, you understand it.
Yeah, and I think most...
About this is how it's going to look like without this part here.
Yeah, but hang on, Alex. What happens? That's a requirement of the heliocentric model, that we have a Pac-Man cutout, like a bite out of an apple, right? That's a requirement of the heliocentric model from the UK. I agree with that. What happens if we go and do the observation and don't get anything at all whatsoever? Are you going to come back with refraction?
No, I'm not going to. Because the refraction per definition only happens inside of the atmosphere, and the most distance that the light travels happens outside the atmosphere, and there's no reason for the light of the sun bending, let's say, away or in the direction of the moon.
I know,
so I'm 99.99% sure you will get exactly this.
Well, I actually think it'd be nearer to 6 o'clock rather than 3 o'clock in terms of the orientation of the shadow. But
yeah,
I agree.
I don't know how exactly it will look like from your position. I had to use a model for that, but
yeah, I agree. There should be
the part that is cut out. I'm fairly sure about it.
Alex, I agree that there should be a partial cutout, right? But to some degree, we should be able to observe it. Now, I'm going to have 3 cameras set up observing it. Some with filters on it, 1 with filter on it, 2 with a partial filter on it, and a variety of zoom lenses. If there is a cutout in the sun, I should be able to capture it because I should be in a position to be able to capture it. But the problem that I foresee is that we don't capture it and we get blamed for not having the right equipment or settings or whatever. But actually, the real world observation would be that you didn't capture it because the parallax on a close moon and a close sun is that much on a flat Earth model that the parallax makes the sun and the moon completely disappear, and we don't see any eclipse at all. And that's what I think we're going to see when we do the observation. I don't think we'll see a chunk like that. I think we'll see a complete sun.
Well,
there's literally no way that you can miss this if it happens.
Agreed.
Because do you have a camera obscura?
Hang on. But my question, Alex, is if we do the observation and we don't see this kind of eclipse that you're saying that we should see, what would be the explanation on the?
Then globe Earth is wrong.
So it's a bit.
Could I just ask a question?
Hang on, he's just said there that's a massive statement. If we do the observation and we do not see this Pac-Man chunk out of it like a bite out of an apple, then according to Alex, the globe Earth is wrong. I think we'll see a full sun. I don't think we'll see a partial sun. I think we'll see a full sun. Yes, Ranty, ask your question.
So if you will be at the position where you claimed you would be in Winter Hill or whatever it's called.
Yeah.
And if Winter Hill is at a position where you can see the solar eclipse, then yes, you will see it exactly that way.
Well, we've established that it is in a position where we'll see it.
The globe is wrong.
So really, it's a big deal breaker. We need to see
I
this.
didn't understand you.
So it's a big deal breaker in terms of the heliocentric model. We should see the eclipse. I agree. We should to some degree.
Yes, under the condition that the weather is alright. Obviously, no clouds.
So what?
If you have clouds, but you can't see the sun. You can't make any claims about it. Obviously.
So what bigger reason do flat earthers need? Basically, from the UK, we all need to look west, look over towards America. And literally observe the sun, whether it eclipses or whether it doesn't eclipse, because if it doesn't eclipse, it's because the sun is close, and the parallax from a close sun and a close moon have parallaxed completely out of the picture, and that's why we see nothing. But if it's miles away, then we would see the eclipse. But I don't think it can work both ways. I don't think that we could have a bite out of the sun like an apple on a flat Earth model.
Yeah, I agree with you, and that's why a flat Earth is wrong. Have you seen a partial solar eclipse before?
Yes.
All right. So why do you still think then that the flat Earth is correct?
Because we saw it immediately overhead. I've got pictures on my phone through a solar filter, and it.
Yes. I mean, you can see it overhead, obviously.
Yeah. But this time it's not going to be overhead. This time it's going to be on our west horizon, setting.
Correct. It's all about timing.
Yeah. But this time it's different though, because if North America is seeing it over their heads at noon, and we're seeing it on.
But you have to understand that the orbit of the moon, not always, or the shadow of the moon, should I say, always hits the Earth at solar eclipses at the same spot. Sometimes it literally hits the Arctic or the Antarctic, and therefore you would have to look north or south. And the angle of the sun then can be directly overhead in terms of it's noon when you see it, but it's still a partial eclipse.
Yeah,
That's
but
what happened 2 years or so ago. There was a total eclipse in, I think, Iceland, and was brilliantly visible from Britain and Germany, and the rest of Europe, obviously, as well.
yeah, but on this occasion, I think it's fair to say that I think the heliocentric model agrees that we should see some element of the eclipse from the UK. Now, my position is
Correct.
we will only see that if it's a distant sun. If it's a close sun, like it appears to be on a flat, and especially the way it's purported to be on a flat Earth model, then we're not going to see that at all. So basically, the observation that we capture, if loads of people do it from the UK, if we all capture no eclipse, that doesn't support the heliocentric model. That only supports a flat Earth model.
Correct. That's why I'm saying you are going to see it.
Happy days. Right, so on that basis, right, Angel, have you got anything to say?
Yeah, do you guys still want to see the model in scale?
I'm all right with it.
I would like to see it.
Sure, go on then.
I would like to see it.
If you can do it, Alex, because
Okay.
I don't think it's...
That would be a little complicated, but I'll try.
So
So,
basically, it's 379 times the difference between
Right.
what the sun and the Earth, sun and the moon is, and the moon and the Earth.
Alex,
okay, so let's go that one in this program that 1 equals 1,000 kilometers. Okay,
Okay.
is it all right? So what we have to find out first is the diameter of the sun. So it's 1.391 million kilometers. God damn it, why is my computer so slow today?
gravity.
You're on a Skype call.
Gravity.
No, it's something different.
Gravity
Maybe I have
has
to
nothing
reset
to
my
do with the
Windows
shape
or
of the
something.
fucking Earth.
It slows mine down.
Using Windows, that's your problem.
No, it's gravity.
Oh, Windows is totally fine. Windows 10 is brilliant, but I think I have no idea why this is the case today. So
It's gravity.
1391000 divided by 2, and we end up with, let's go for 70,000. Is that all? Not 70,000, 700,000. Is that all right?
Sure.
So we would have a circle.
Not a sphere.
Yeah, I mean this is two-dimensional, obviously. So let's go for 700.
Who's outside?
Zoom out a bit. So here we go. That's the sun. Okay.
Okay.
So the Earth is 150 million kilometers away. That means that the Earth is at 150,000.
150,000 mil... Well,
it's in this model or in this program. So that's about there. 150,000. No. This one.
I'm actually enjoying you doing this, by the way.
And the Earth has a radius of 6,000 kilometers, so the radius is 6.
So the kilometers...
Let's go for 6.38.
Alex, 93 million miles is 150 kilometers, 150 million kilometers, yeah?
Yes, and
Okay.
then this my model is in scale 1 to 1,000, so I have
yeah,
to
yeah.
put in 150,000.
Yeah, I'm just making sure that we had the distance right.
Yes. So you see how small the Earth is compared to the Sun, obviously.
Yeah.
Yep.
All right, and the Moon is 300,000 kilometers away.
But if you were to draw two parallel lines from the sun, so that they intersect the Earth, it would.
Let him do
No,
this first.
first of all, we have to draw the moon first, okay?
Okay.
So that means it's at 147,000. Is correct?
240,000 miles is.
One is a
10,000.
10,000.
386,000, Alex, kilometers.
Yes. Let's go for 400. Is that alright for you?
Sure.
So then it's at 0.4. So 46.
Are you still?
97.
Are you still with us, Angel?
No.
Here
Okay.
it is. Alright. And the radius of the moon is 1,700, so it's 1.7. So, just to inform you, this is actually the correct scale of the Earth-Moon system. Okay? So, let's zoom out a little, shall we?
Well, what I'd like you to do at this point is put two horizontal lines from the sun back towards the moon and the Earth.
This is fine. This is fine. I'm happy with what
They
you're
are not
doing.
going to be exactly horizontal.
But
They
I
are.
want you to do the same.
They are,
same
though.
line system that you put in before.
They are.
Make
Yes,
it
that's exactly what I'm going to do.
No, but hang on. You need to put it into context as well, though, because you need to show that there is light coming from both sides of the sun, not just the penumbra and the umbra.
Well, no. Let's honestly.
We need to get the shades of the Umbra and Penumbra first. Do you agree?
Well,
I
no,
agree.
no. I think you should show two parallel lines of light coming from the sun first.
How do I move here? Ah, okay. So
Tinfoil Hatter, I agree.
I hate this program. It's annoying.
I agree with Tinfoil Hatter's comment. Because the moon is supposedly so big, then it should make a much bigger shadow than it does, right? I think I agree it should make a shadow the same size as the sun, but I don't agree it should be bigger because the light source is bigger, not smaller. It would do that if it was smaller. Whilst Alex is fumbling and messing around here in terms of getting it set up.
The program is extremely annoying.
Yeah, it's okay.
When zooming in and out, it's not made for that because. Is it D? It's D.
And just to recap for the 46 that are watching right now, Alex has said that if we fail to observe any eclipse at all from the UK when the North Americans are getting their solar eclipse, if we fail to get any eclipse
They'll write us
recorded,
a check for $1.2 million.
it means that the heliocentric model is wrong. It means that the heliocentric model is wrong because we should see an eclipse. Maybe not a full eclipse, but I think it's about 20%, but Alex says maybe 15%. But in any event, there should be evidence of an eclipse from England. And I think we're going to get it completely like a normal sunset, because I think the sun and the moon are close, a lot closer than they tell us. And on that basis, on that model, we would get no eclipse whatsoever, because the parallax caused in a close sun compared to a distant sun is huge. So we would see no sunset at all. Sorry, we would see no eclipse at the sunset at all. But Alex has stated on the record that if we fail to observe and record an eclipse, then the heliocentric model is wrong. And I'm looking forward to doing this observation because I can do this quite easily.
What the heck? Jeez.
So then the question becomes: are you prepared to denounce the ball, Alex, if we fail to record any eclipse? Because I tell you what,
Sure.
there's not many. Yeah, I agree. I'm prepared to say that the sun and the moon are as far away as what they say. If we do observe any element of eclipse, because we shouldn't be able to do it on the flat Earth model, because they are close. The parallax on the flat Earth model is that much that we would get a totally normal sunset. But on the heliocentric model, it's minuscule, and there's not many observations that can be so different. Usually when we do observations, they're very, very similar and we can't distinguish one over the other. Some people say it's curved, some people say it's not. Some people say it's barrel distortion, some people say it's not. Some people say it's atmospheric refraction, some people say it's not. But on this one, if we see eclipse, that supports heliocentrism. If we don't see any eclipse, that really doesn't support heliocentrism. It really supports that the sun and the earth are close. Sorry, the sun and the moon are close. And the parallax that would have happened on a flat earth model was that prominent that we see no evidence of an eclipse.
Hey, Alex.
Yeah.
If we were to take a aluminum-shaped egg,
An
about the size of
aluminum-shaped egg. You mean an egg-shaped piece of aluminum?
Yes.
Very good, Alex.
Yes, that is what I meant. I'm sorry. and we were to, I say that because it's a very structural shape. And then we were to make it a vacuum. Would it, because it's a vacuum, have buoyancy, or would we need to actually put helium in it to get lift?
No, in a vacuum, per definition, you don't have points.
Okay.
So annoying. I hate this program. So for some reason, when I click here, so you guys see when I try to move the entire thing, I lose the line that I want to draw. Really crappy at this. I'm sorry. Actually. Still not better.
For those in chat that's just paying attention here, Hillel Finder's asking me, so, if you do observe the eclipse, and it's the same as predicted, then what? And I'm saying then I'll denounce flat earth concept because the sun and the moon must be far from us, right? Did you show them
Alex,
my model?
Is Alex still sharing?
Yes, I
Sorry,
should
Alex. Yeah, if you stop sharing for a moment.
Hang on.
You might find that it's easier to work with your program and then come back when you've actually sorted it out.
To be honest, it shouldn't.
Well, actually,
Just give me a second. I
yeah,
just have a different idea on how to do it.
it's all right. Give him a second because I'm sharing my screen anyway. This is an observation prediction that Hillel Finder has done, and according to Hillel, this is what we should see of the sun at the top of Winter Hill, which is where I can get to really easily. Ranty could probably get to it quite easily, but Ranty's thinking of doing it at the tower in Blackpool because it's looking out over the Isle of Man. Now I'm thinking of getting from a higher elevation point, but the distance to it and from it is negligible. But it's the elevation that's important because we need to get beyond the Isle of Man mountains. But he's basically showing that the sun setting at different times is showing something, but I don't know what these other suns are. So he's showing that from where we are on Winter Hill, at these degrees of observation, we should be seeing the sun setting at these times, which I don't really dispute. It's just what do the others say? I don't really understand it, and I've tried to speak to Hillel offline, but I've not been able to get in touch with him properly because he's been busy. Although he's watching the live hangout right now, so he's not that busy. But it appears that we will see a sunset. It appears that we will see some element of an eclipse. But this is a really big deal for flat Earth because if we don't see this evidence of an eclipse, then it means that the Earth. Well, basically, we should see it. It means that the Earth, in relation to the sun and the moon, if we don't see the eclipse, means that it's close. If we do see the eclipse, it means that they're far away. And like I say, it's not often we get observations where we can contrast, obviously, and say this is clearly right or clearly wrong, because they're often, you can't tell either way. There's such a minute margin of difference between the two that you just can. It's down to your own interpretation. Well, yeah, I'm going to put my flat Earth beliefs on the line with this. I'm going to say that I believe we will see a complete sun with no eclipse, and that will support flat Earth. If we see an eclipse, if we see elements or evidence of an eclipse on the sun, then that supports the heliocentric model completely, and the sun and the moon have to be far away. Whether it means that it's around Earth or not is another issue, but it means that it supports more. It's a lot closer to the heliocentric model than anything else I've come across, because we should not see any eclipse on a flat Earth model.
Alright guys, I almost have it.
Sure, I'll go back to you now.
15 seconds.
Right, we're back on with your screen now.
It turns out I can simply click on the left side the points that I have marked, and it will automatically connect the lines for me. So Yes, now it should work. So are you already sharing my screen?
Yeah, we're watching.
Alright, so this is the sun, and at the bottom and the top we have 2 lines each. You can, in this case, only see one line because they're almost parallel, but you can see the of them being not parallel when we take a look at the moon. So yeah, you see that 2 lines are hitting the top part of the moon, the North Pole, and 2 lines are hitting towards the South Pole. Do you see that?
Yes. Ranti, are you paying
Alright,
attention?
so-
This is for your benefit.
Yeah, I'm paying attention.
So,
Yeah.
so you guys have seen that this model is roughly to scale. I mean, for example, I don't know whether we are at the perigee or apogee right now. I would have to look it up because it would change a little. And in the case of solar eclipses, this little is important because of ring-shaped solar eclipses. So as you can see, the umbra is the part between this light right here. Actually, I'm going to give it a different color. Let's go for a dark green. I hope you can see that. So, as said, everything between the 2 green lines is the umbra. Everything between the black line and 1 green line is the penumbra. Okay? So let's see what happens when this stuff hits the Earth. Alright. As you guys see, the umbra itself is relatively small.
Relatively small. What would you say that was? 50 miles?
I think it's in this case a little more because, as said,
You think?
the model is not.
You think it's more than 50?
Yes, let's check it. Okay.
Okay,
So-
I would like you to check that.
So I have to find the scale for the y-axis, but I think it's roughly identical. So this is 0.4. That means that this is this is 0.2. That means that this here is about 500 kilometers right now. But as I said, first of all, I've drawn the moon a little bigger, I think, than it is, and the distance is not perfectly correct. If we look a little further, just about 40,000 kilometers more, there will be no more umbra whatsoever. Do you see that? Here's the point where the 2 lines cross over. So when the surface of the planet is farther away than here, which is possible because, as you guys know, the orbit of the moon is not perfectly circular, it's an ellipse. So in this case we would have more or less the maximum amount of eclipse that we get, and if the Earth were a little more far away we would get a smaller solar eclipse, or in this case over here a ring-shaped solar eclipse.
Oh. Well, could we just go
So
back
as
to
you guys see, the umbra is definitely smaller than the moon was.
Okay.
And the penumbra is bigger, definitely. As you can see, when the diameter of the Earth is about 12,000 kilometers, then the diameter of the penumbra is about 6,000 in this case.
Yeah, but I really want you to add the other lines in that I've asked you to add in.
There are no more lines to add in.
Yeah, there
I
are.
don't think it really matters.
It does.
I think
It does
the-
matter.
I think
Hang
the
on.
moon's too far away, but that's beside the point.
Hang on. Well, we can check it. We
But
can
even
check.
So, even on this model now, I'm believing that we are looking at least 500 miles of coverage, total coverage on the Umbra. At least
Yes,
500 miles.
as said, first of all, I'm not sure where exactly in the orbit the Earth is, because as you guys know as well, the Earth's orbit is also not perfectly circular; it's also elliptical. So
Yeah, that's
we
got
would have
nothing.
to check it to
That's
refine
got nothing to
can I
do with.
just-
This.
can I
Hang on.
just say, though,
Wait.
that
That.
you
Hang on.
did
Wait.
this
Ranty.
model,
Wait.
And you said that
Ranty,
it would be
wait.
50 mile.
Fucking hell. Wait. The position of the orbit of the Earth has got nothing to do with the size of the
I've only
shadow
said
that's cast
2
on it.
words in hour.
Yes, Anthony, the position of the Earth, where exactly the Earth is in distance, the distance to the Sun, is indeed relevant, because the angle of these lines will change a slight bit, and that will have a result on the diameter of the umbra and the penumbra.
No, I don't agree. Ranty, ask your question.
Yeah,
I
when
mean,
you
I
first...
mean, and Anthony, wait. I mean, look at this one here. this is obviously not to scale, and look how big the angle here is.
Agreed.
Now, so you agree that the angle of the penumbra changes depending on the distance between these two objects, right?
Yeah, but this is at high noon this is at solar noon, at high noon in North America, so the angle's going to be, it's going to be perpendicular to the sun and the moon. There's not.
The angle of the penumbra is independent from the position of the sun as seen from the planet. For example,
You just said it was related to the orbit.
North America in this case will be here. So the shadow, you realize that the moon is coming from one side and is going around the planet. So what will happen is that the umbra will come from one side here and, let's say, from the top and go downwards.
But I agree with I agree with Ranty's position. It's going to be it's going to be nearer to 1,000 miles of a shadow, not 500. It's going to be huge.
It's going to be a lot more than that.
Yeah, I agree.
Let me
I'll
just
tell
show
you
you.
why.
I'll
tell you for why.
Wait. Let's just go about 50,000 kilometers farther away from the moon, right?
Well, can you put the moon in the correct position?
It isn't the correct. Wait.
Well,
I don't.
one reason I think that it might be smaller is because you're going to get diffusion of the light when it's coming through the atmosphere.
No, because the light rays that will hit the surface of the moon are not in the atmosphere. If you would have any light bending that would influence the shape of the solar eclipse, or at least as seen from the planet, then that would have to happen over here or between the sun and the moon, and not in our atmosphere. And when you're in a vacuum, you don't get any refraction or bending of light whatsoever, per definition.
Well, I'm saying diffusion, not really refraction. I mean, that's fine.
Yeah,
I don't think it's going to be a whole lot because you're only got 8 miles of atmosphere, but you're
okay. So again, let's
shrink
go
it
back
from
to our
500
model.
miles to 470.
Yeah, the only thing that has to happen is when the Earth is a little further away from the moon, or when the sun is a little further away from the Earth-Moon system. As you can see, the lines cross over here at about 150,060, so that's 60,000 kilometers further out. That's, for example, the reason why we sometimes get ring-shaped solar eclipses, because that's the point when the solar eclipse happens while the moon is the farthest away from the planet.
Well, doesn't the moon and the sun, doesn't the moon and the Earth stay equal between each other apart from 3 inches per year?
No, they change their relative distance every 14 days or every 15 days for about 40,000 kilometers. And that's more or less the range that we have here. So when we look up the... Just give me a second. Why is my fucking Chrome so slow? I have no clue. Maybe it is Skype. Oh, it's the crappy internet. I don't know. What the heck? I've never witnessed that my surface is so slow. So for those who are wondering, this is indeed quite a powerful laptop, but for some reason it behaves quite weirdly today. I mean, this has a Core 5 and it's a 11-inch screen, so let's go for orbit of the moon.
It's playing badly because of
Gravity has nothing.
It's because of gravity. Gravity.
Fuck. This doesn't work.
It doesn't matter if it doesn't work. Yeah, we're still here.
I'm not talking to you, I'm talking to my computer.
Oh. Your computer speak to you?
No. But I'm talking to it when I wanted to have be faster. So, shit.
It talks to him a bit.
It's of the moon.
Well, Anthony, could I ask you a question?
Sure.
Well, we know that the distance between the sun and the moon, and the distance between the Earth and the moon, the comparable distances between those two sets of distances is 379 times. In other words, you could fit 379 times the distance between the Earth and the moon as you could to the sun.
Yeah.
If we believe the model, okay. And I know that there has been talk about that it will always be a larger in width shadow that's cast upon the Earth. Now, I disagree, and I would say that what you need to do is to divide 100% by 379 to get the actual amount of distance, percentage that you would actually lose of that shadow. So I think you would actually lose 0.26%. So you're actually going to see 99.74% basically of the width or the the diameter of the moon. This is my theory on it. This is what we should see.
So I just looked up orbit of the moon in Wikipedia, and what we see is that the distance between the Earth and the moon, so it's the distance between the perigee and the apogee. So the perigee is 362,600 kilometers, or 225,300 miles, and the apogee, which is the maximum distance from the Earth, is 405,400 kilometers, or 251,900 miles. So you see that there's roughly a 43,000 kilometer difference. Do you see that?
About 10%.
Yes, about 10%. And now when we go back to my model, we see that the point when there's no more umbra is just 50,000 or 60,000 kilometers away from the planet. So when we take this 40,000 kilometers farther away from the moon, plus we add the few inaccuracies that are in my model, then the distance or the size of the umbra of the 50 miles that I said previously is more or less expected.
What I'm going to do, Alex, I'm just going to share...
You're saying that the moon stays in its same orbit and it's just the Earth that moves away?
In this case, yeah, it could be, because the relevant
Wouldn't you think that the moon and the sun...
Wait. The relevant distance is the distance between the moon and the Earth, and that changes by around 10%. So you will get a different result. So the shadow of the moon will hit the Earth either here at this position, or anywhere further away until about here. Plus I don't know, maybe 10% inaccuracy or so of my model. But what you can see from the model is that compared to the size of the entire system, the length of the umbra is not much longer than the distance between the moon and the Earth itself. So, as I said, a diameter of the umbra of 50 miles or less even is within the range of the accuracy of the model that I drew.
So you're saying that if the Earth moves away, then the moon is going to stay in that same position?
Relatively, yes. As I said, the only thing that my model currently cares about is the distance between the three objects and the size of the three objects.
This is what I'm interested in. I don't think you have the moon in the correct position.
We could do the
to
same.
Start with.
We would get the moon, and we would get the same result by moving the moon further away in this direction by 10%.
Yeah, but I don't think that your moon's in the correct position to start with.
Okay.
That isn't 379 times further away than the Earth, between the distance between that and the sun.
Shall we calculate it?
Yes, please.
Okay. So, by the way, I set this to 400. The distance. Oh. Yeah, it's the distance is currently 300,000 kilometers, so it's less than the actual distance. That's the problem. You see that I set the distance from 150,000 to 149,700. So the distance in this model is currently 300,000 kilometers. That's less than the perigee. Here's the problem. You see that if I move the moon further away, then the Earth will be closer, or the shadow will be closer to what we see in reality. I can do the adjustment
I think the moon should be much closer to the Earth.
No, it isn't.
Well, zoom out a bit, Alex, because it's less.
Did you say you was going to measure that?
So let's just measure it.
It's
so
less.
The mean distance. Let's go for the mean distance. Okay.
This is fine.
So the mean distance is 385,000 kilometers. Okay.
Yeah.
385,000. Let's do it the other way. So the distance between the Sun and the Earth is 150 million kilometers. Okay, 150 million.
Well, can't you just divide the numbers that you have on the left
Yeah, it's
and see
now
if you end up with 379?
Yeah, he wants you to apply it to your scale to make sure that your scale's correct.
Exactly.
Yeah, let's just go for the official numbers first, and then I go with mine, okay? And then I'll explain why mine was incorrect until now and why we have to change the position of the planet. So 385,000. And we end up with 389, 390. Is that okay for you?
Okay.
So now, until now, in my model, the distance, so we go for 150 million again, and divide that by the 300,000. And we'll end up with 500, and here's the problem. Because, yeah, the distance is only 300,000 kilometers. It should be 385,000. Agreed? So what we need to do is place the Earth further away. 10,000, 20,000, 30,000, 40,000, 50, 60, 70, 80, 85. Right there. What the fuck, 65? What's going on? What the heck? Zero. No. 150,000. 85. I hope this works. It doesn't.
No, you have to do it the other way.
I'm going to just zoom in a little. So. There we go.
No, you have to do the distance between the Earth and the Moon, and then you have to divide that by the Sun's distance between that and the Earth and the Moon.
I assure you that this is accurate enough when we do the calculations, okay? I can show you. So, forget this position of the Earth, that is more or less incorrect. At least it's more incorrect than this one. So, here we have the median distance between the two objects, okay? And what I'm going to do now is I'm going to draw in the maximum and the minimum position. So first of all, let's delete B. Alright. So the minimum position, 362,000. Okay. So 700, 365,000. Right there. Yeah, that's good enough. And I put G 405. Not Chrome. Ah, fuck. So that's.
So which program are you using, by the way?
This is called GeoGebra. It's actually a program.
GeoGebra.
Whatever. It's actually used for teaching high school students geometry. So I think it's quite alright to use it with you guys. So.
I'm more elementary school.
I'm Crash.
You know what? I believe you.
I'm kindergarten.
Do you use 3D calculator or geometrics calculator? Graphic calculator?
So let's go for 105,000. So this would here be the so F is the maximum distance between the Earth and the Moon, and B is the minimum distance. Okay. Now, as you see, the point where the two lines, the important lines that define the umbra cross over, is more or less exactly at the perigee. So let's just draw the Earth in here, 6.3, right there. That's when the Earth is closest to the, whoa, that was not my intention. And let's draw over here, also 6.3. All right, so, and now when we check out when the Earth or the Moon is at perigee, we get this very small umbra. Do you see that?
Ranty?
Yeah, I see what he's trying to show, but I'm still saying that the moon is in the wrong position in relation to the Earth.
No, it's not.
It's too far away. It's too
No, it's
far
not.
away.
No, I can show you. So you said the we had it over. Where did we have it here? You said the relation of the distance between the Earth and the Sun would, and the Earth and the Moon would be 389.6.
Right. Okay.
Okay, so that's exactly the ratio. So let's go for the actual numbers that I got here. Obviously, it's changed a little because I had to adjust the distance of the Earth to change the 4 lines, but the results are approximately identical. So let's go for not task manager. So the distance between the Earth and the Sun is now.
No, the Earth and the Moon. The Earth
Yes,
and the Moon.
Yes. The important thing is the ratio. You said it
Okay.
yourself.
Okay.
So 150 million.
This is between the Earth and the Moon.
Wait, no, this is between the Earth and the Sun, this number. But it's
Right, okay.
150 million and
No, a few more.
80,000. So this is the actual number that I'm, not 8,000, damn it. No one. So this is the actual number that I've got here in my model. This is the
Okay.
median distance right now, okay? And now we have to divide this. So 780, so that's 380,000. And we end up with 395. So as you see, the difference between the actual thing and my model is less than 0.3%. So, as I can show, the Moon is now approximately in the right position. And
Okay, I'll need to recreate this myself.
sure, I recommend you can download the program. I can even send you the data that I was using. I can save the file and send it to you.
Okay.
So that's no problem whatsoever. So this is Earth.
It still doesn't make any sense in my mind as to what we should actually be seeing.
I actually demonstrated right now that it did. Or that it
Yeah,
is.
no, I think something is wrong here. Just saying.
Yeah. So we can go back and
I need
check
to
if
figure
you
out what
want.
it is.
We can now check if you want the size of the umbra that we're going to expect. Okay. So this is here the optimal case when the Earth is closest to the Moon, and as you can see, the umbra ends approximately at the center of the planet in this case. And the further away you go from the Moon, then the bigger the ring of the solar eclipse when its ring shape will be. So when we zoom in here, remember 1 unit is 1,000 kilometers. So since this is 0.1 kilometers, we would have here a diameter of about 300 kilometers. We would have an eclipse of 600 kilometers diameter with the totality zone. But when we only go 1,000 kilometers more away from the Moon, this shrinks substantially. So here we have, so this is at 150,058, so we would have to go for 150,059. 59.1. So here it's only 250 kilometers, and the farther away from the moon we go, the smaller it will get. And the 3,000 or 4,000 kilometers that we have here is definitely within the range of the accuracy that I used my model in. If you want to do it more accurately, you can use the numbers up to the kilometer or to the meter of the given values. But I think in this case, this is accurate enough.
Yeah, I mean, I think the thing with myself is I like to do my own maths, and when I'm seeing somebody else do it, I kind of get a little befuddled. So I'd rather just do things to like 1,000 miles is 1. 2,000
yeah, that's what I'm doing.
Two.
The only difference is that I'm using the metric system because, first of all, I'm used to it, and second of all, it's a little more accurate.
Okay. And I like to do my own stuff myself, and then, you know, you could be right. If this is true, what you're showing, it makes sense from what you show. But it doesn't make any sense to me, because from what I know, that the distance between the moon and the Earth, and the distance between the moon and the sun, there's a 379-fold difference between each, which should mean there should be only a 0.26% drop in the actual.
But that's not a constant ratio. That's an average.
Yeah, that's the problem. The distance between the Earth and the Moon changes, and the distance between the Earth and the Sun changes a little. The value you give is a median. That means that there are various possibilities. So the number can be a little bit larger. It can be a little bit smaller. If it's a little bit larger, then you will have a total solar eclipse. If it's a little bit smaller, then no, wait. No, if it's larger, it will be a ring-shaped solar eclipse. If it's smaller, then it will be a total solar eclipse.
So let's say it's furthest point away. It's 300 times the distance between each. That's only a 0.33% drop of shadow loss. You should still get over 2,000 miles of shadow.
You got something wrong. The 300,000 that I used in the beginning was wrong. This never occurs. The minimum distance between the Earth and the Moon is 360,000 kilometers. Then the ratio will not be the 300, it will be slightly bigger. But what you can see here clearly, I mean, along
that's right.
Points,
it should be
is that you can clearly get a total solar eclipse with a very small umbra, or you could get a ring-shaped solar eclipse. Here just a little, with a little ring around the circle of the moon, and here with a bigger ring of the part of the sun.
Alex, would you be happy to come back on Monday? Give me a bit of time to look through this and have a chat with you on Monday about it.
I don't know if I'll be online on Monday, but I will host a hangout tomorrow, 1700 UTC probably, if I get the confirmation from Nambi.
Okay. Okay, I could work something out between now and then.
So if you would want to join, then you can certainly do that afterwards, after I've talked to Nambi.
Right, guys, can we move on? Because I want to play this flat Earth video. It's basically a projection of what should happen on a flat Earth. So Alex, if you want to stop sharing your screen.
Sure.
In Skype, remember.
Yes. How do I do that? Here. No. Yes. Okay, you shouldn't see my screen anymore. By the way, what I'm going to do immediately is send you, Anthony, the file.
Okay. Well, just hang fire, because I want to play this video.
Sure.
I want to play this video for all in the chat. This has come with permission from Cosmic Surfer, and I believe it's a flat Earth projection of what the eclipse should look like on a flat Earth. But I haven't seen this before, so I don't actually know what it is. So the start of the visible shadow, I'm guessing it's going to be... Right, he's showing this every period of time. So this is like a time lapse, I'm guessing. Speed it up a little bit. Right, so this he's showing... I don't know if this is on a flat Earth or on a ball Earth model.
No, it looks pretty well. The projection is flat.
Yeah, but what?
You can see it going across the U.S.
Yeah, but it started off very elongated.
Who's to say it won't truly be?
Well, look, it's going elongated again now, isn't it?
Can you guys just give me a sec? I can't see it yet.
Yeah, you have to kind of. I'm watching it on YouTube, so he's gonna have to rewind it.
Yes, that's my point. So
I should have changed the scene over so that you guys could have seen it.
So it alludes that you won't actually. You might be able to visually see it, but you won't be able to actually be in any of the shadow. Because it looked like right at twilight, it was still in the.
He's saying, look at the moon and the sun position, which is this bit down here. You can see this light looks like an egg. Right, Cosmic, is this on a flat Earth or is this on a ball Earth model? Because it looks to me like it's on a flat Earth model. Yeah, this is on a flat Earth model. Now, if this is on a flat Earth model, Cosmic, would you agree that if this is on a flat Earth model, we would not see this from England? The parallax
Whoever's
would be...
watching YouTube, turn down your audio.
I'm just hearing cars go past.
By the way, guys, have you guys taken the chance and looked at the eclipse using how is it called, Celestia?
No.
Because Celestia, you can use actually Celestia to predict the eclipse quite accurately.
Maybe Kara could model that for us. Or do you know how to use it?
What, Celestia?
Yeah.
Sure,
Do you want to do it?
of course.
Okay, then go and share your screen again then on Skype, and then we'll,
I just don't know if my computer will do it. Because maybe it's energy saving mode or something. No, it isn't. Weird. Okay, I'm going to share my screen again.
All right. But let's just check while you're loading that up, Alex. If we fail to record any evidence of the eclipse, it means that the sun and the moon are close and they've parallaxed out of position, right?
Under the condition that you have a clear sky during the eclipse, yes.
And if we do observe the eclipse, evidence of the eclipse, I will agree that the moon and the sun have to be far away. They can't be close. Kind of rules out the idea of a flat Earth model for me.
Yeah, that's fair. Okay, do you guys see my screen?
Yes.
Alright, so we have here a model of the solar system. I've basically switched off everything beside the Earth, the Moon, and the Sun. So, for example, we still have Mars here, but all the other orbits of the other planets are not seen right now.
Okay.
So what I'm going to do now, it's a little shitty to do this without a full-size keyboard, but I'm going to try anyways. So, first of all, we're going to set the time. So, do you guys know the exact time when the eclipse will happen? It's the 25th, I think.
It's about noon in North America, and it's about that time, 2040 for us. I think it's 2050.
Yeah, I don't know if I can set the time for the exact minute.
Just get the day, I'm sure it'll be close enough.
Yeah. Can you guys look it up? Actually, I'm going to find out. I have a better idea. So, no. What?
August 21st, 1546 Universal Time.
August 21st. Okay. Good. Alright. So what I'm going to do now is I'll approximately position myself between the Earth and the Sun. Okay. It doesn't have to be as accurate because I want to see both celestial bodies at the same time. I'm going to get a little farther away so that the parallax effect is a little smaller. And then what I'm going to do is I'll zoom in. So everything I'm doing right now is I'm zooming in. I'm not moving towards the Earth, the moon system, I'm just zooming in, okay?
Yeah.
And what I want is, I want to see more or less this. So time is running backwards right now, so don't question it. So I can control everything here in this program. Adjust again. So we're now at August 21st at 1:49 UTC, alright?
Okay.
Okay, I'm going to position myself a little bit better. And now, going to zoom in a little further. Okay. So. Okay, so. As you guys can clearly see, here's Asia and here's Australia, right? So time is running forward right now. Just a little more zooming in. Adjusting. Alright, and now I'll quickly increase the speed of time. You can see that it's now 3 UTC. Are you sure it's August 1st?
21st.
Ah, yes, yes, here it is. So I'm currently not... that's much better. I've just corrected my position a little. So, as you can see... This position is perfect. So, time is now running forward again. And what I'd like you to do is look at this position here. We have here North America, South America, Africa over here, and Europe right over there. Do you see that? Can you guys see it?
Yes, yes.
Alright, so I'm going to start the simulation running now. And I slowly increase time again. Factor 1000. Look right here. The shadow will appear here. There it is. And it moves across North America, right over here, over the Atlantic. And then it leaves the Earth about here. Now backwards. Again. Diagonally through the United States. Stop. So it should start at about 1639 UTC. That's when the umbra actually touches the ground first. The penumbra obviously a little bit earlier. And then you see here again, it goes diagonally across the United States, then hits the Atlantic Ocean and leaves the surface of the planet at roughly 2025 UTC. That's the umbra, not the penumbra. And you can see that part of the penumbra is still visible over here.
Now, I would like to point out it puts a really big shadow on the Earth.
Yes, and that's what we expect. Because, as said, penumbra basically only means that not the entire sun is visible. That you will see this, quoting Riley, this Pac-Man effect. That's all that the shadow does.
Can you show it from the Earth's position in terms of the sun?
Oh god, I try, but I can't do this.
Be right back.
I'm zooming towards the Earth. Okay. Actually, before I do that, let me reset the time so I don't get confused. So, time is running backwards. And stop. Okay, I'm zooming towards the Earth. I hope I don't fuck this up because this really isn't easy. Oh, I'm still far away from the planet. That's not... We can't forget that. So I'm at 2 million kilometers. Let me zoom in further. 20,000 kilometers. So you guys can see the distance between the position of the camera and the Earth here. That's currently at 8,400 kilometers. And here's the date, the time, everything. So what I'm going to do is turn around and find out where the sun is. I don't think this is very accurate. in terms of I don't know if I'll stay above the same position of the Earth or not. Actually, it's a little out. What I'm going to do is I want to have more field of view, so this looks a little weird, but okay. Let's begin. Okay. And yes, as you can see, before the eclipse, here we have the moon and here we have the sun. And now, time is set to forward. Let's let this run. As you can see from the position that I've shown, or chosen, and we zoom in, this is what you expect. Now, this is obviously not in the totality zone, but this is more or less what you will see. I don't know in which orientation though. Hello?
That's pretty promising. I mean, pretty
Impressive.
very well illustrated.
Yeah, it is well illustrated.
And again, this program does not have a database with the eclipses or something. All it has is the orbit of the moon, the orbit of the Earth around the sun, and yeah, that's more or less all we need. And obviously the sizes of the three objects. But it does not have a database with the eclipses. And we can use this to predict more eclipses and go back in time and watch the ones that happened, for example, in 1999 across Germany.
Yeah.
Which I did. We can replicate it if you want.
Yeah, which is fine. I mean, you're showing it on a model, which is fine, but this is the question: does it match the reality when we're doing it from the UK? Which is what you're saying we should. Is that from the UK? That one?
I don't know. Because this program isn't really made to pick a specific location on the surface of a planet and watch what happens. I just zoomed into the Earth and hoped I would hit the right position.
A location in the solar system.
Yes, exactly. What we can do it with Stellarium. But I don't know, do I have Stellarium on this machine?
Do you know how to use Stellarium?
Yes, I do. I just have to download it. So I just stop screen sharing and download it, and then afterwards we can do it. Okay.
Just tell Microblogganism I gave him a shout out. I saw on your Skype then it was a. I saw on your. I
think he's currently doing a hangout himself.
No, well, just let him know that I gave him a shout out.
He's doing a taking a look at right now. Taking a look at is his hangout.
Okay, so basically what you're saying there is that we should see. Thank you very much. We should see some of the eclipse. So basically, let me just reassert the position because we've said it once before and I want to say it again. Alex, will you denounce the globe if it turns out that we get zero evidence of the eclipse?
Under the condition that you saw the sun directly, yes. That means if you have a cloudy day and you can't see the sun, then you can't say that you didn't see any evidence.
No, agreed. If we get a clear picture, of the sun, and I'll have 3 cameras set up. I'll have one with a solar filter on it, one with a partial filter on it, and the other one that's naked. That'll be the P900 at full zoom. Then we should get a variety.
It's the best idea to use the P900 with the solar filter. Because that one has a zoom that is good enough, so maybe you can see at the edge of the moon, of the disk that you see of the moon, you might be able to see the shape of the craters with the P900, but not with the other two.
Sure.
So I really recommend that you use the P900 with the solar filter, because that will give you the best results, in my opinion.
Well, that means I'll have to buy a solar filter then, because I don't have a spare one for another camera.
Yes, I think you can grab them quite cheaply at Amazon. Like 10 by 10 centimeter filter paper, you can just strap it with a rubber band across your lens, and that will work.
Sure. Okay, well, what I'm going to do then is I'll get a solar filter then for that. While I switch that one back, that's better. I'll get a solar filter for the P900. I'll put a solar filter on me Mega Zoom camera, See, I'm actually going to need 3 people because one of us is going to have to control the P900, the other one's going to have to control the big camera with the 5500mm lens equivalent on it.
Wait,
And
you're telling me the P900 doesn't have a thing where it can take a picture every like 10 seconds or something?
yeah, it does. Yeah, you can do time lapse.
Why don't you do a video?
Because it'll be a video of what? The P9.
Because-
Yeah, I'm going to do it as a video. That's right. I'll do it as a video. But then again, people will say
Alright,
you should have.
Just make sure that you zoom in to the max and readjust the camera every 30 seconds or so, because you know the sun is actually moving during that time.
Some people would argue that stills are better than video. If I give you video and it shows no thingy, will you accept it if it's a clear view?
Yes. Can you do both, maybe?
Well, what I'll do is I'll do a video on the P900. I'll get the missus to do some stills on her D500, but it'll have a different zoom on it. It'll be zoomed out.
No, I mean there are some Canon cameras where you can take a video, and when the camera, or when you want the camera to shoot a still, you just press another button and it will take a still while still making the video.
I can try that, yeah.
The P900 has this function.
I can try that. I can work out how that works on 2 of the cameras because I know the D500 does it.
The manual.
Yeah, I'll have to read the manual, but yeah, we should be able to do that. A video with photos as well, yeah.
Yeah, that
And but in return, I'll put my balls on the thing and say that if we do get evidence of an eclipse, that means that the sun and the moon have to be far away and they cannot be close. Because do you agree that the parallax would have been that massive that the moon would have passed it miles and we would get
yes.
right?
If the sun and the moon were near, you wouldn't be able to see it.
I actually think this is probably the best test that I've been able to do, because it's really rare that we get observations that are so contrastingly different. Normally, they're so similar that you can't.
You can go out on Monday night and watch a lunar eclipse.
What are you talking about?
Because on Monday night there will be a lunar eclipse.
On the moon?
Yes.
From England?
That's usually the case just before or just after a solar eclipse.
Oh, right, okay, yeah, okay. So from England we can see a lunar eclipse?
I think we should, yes. I think it's at least visible from Germany, so it's reasonable to assume that you can see it from Great Britain as well.
Ranty, what are your thoughts at this point?
In regards to which?
I'm prepared to put my balls on the line and say that if we see evidence of the moon passing in front of the sun from here, that means that the sun and the moon cannot be close. I'm prepared to accept that they are further away. Do you agree, or do you think that? Do you have a different view?
I'd like to keep my powder dry for now. I'm not going to put my credibility on the line or any kind of anything on the line.
I will. I'll say that if we see evidence of the solar eclipse, that means that the sun and the moon have to be far away. For me, it's black and white. They can't be close. But equally, if there is zero evidence of the moon passing between it, that means it's parallax past it, and the moon and that's inconsistent with the heliocentric model. And Alex is going to concede that the model doesn't work.
Well, at the moment, my
Yeah,
head's
Anthony,
still spinning from GeoStreamer before when he showed the distances between the two and how little actual shadow it cast on the Earth. It doesn't, in my brain, it doesn't compute. On the model, it seemed to show that it works. Now,
the little part, the central part of the shadow is quite small, yes. But as soon as you don't see the entire sun, you're per definition in the shadow. So the big part, the 2,000 or 3,000 miles that I was showing, is it's getting more dark from the outside of the part to the inside, and when you're reaching the umbra, then you can't see the sun anymore at all. So yeah, it depends a little on how you define the shadow.
Angel, are you back yet?
I didn't go.
By the way, another thing.
Well, yeah, I've been back for a while.
This is not the first time that I've seen a partial eclipse. I mean, I won't be able to see this one because it's not visible from Germany.
Yeah, I think you're too far.
I would have to drive to, I don't know, at least
France. Yeah.
Spain, I don't know.
I agree. I think that you're too far away on the heliocentric model. You're too far around the ball. But we've got a line of sight to it pretty much just before it sets over the western horizon. So we're in a really cool position. And the further south we get, the better. But I'm all right to see it where I am. But Angel, what do you think? Do you agree that if we do see evidence of the moon passing before the sun, from England, that means that the sun and the moon have to be far away. They cannot be close.
I'd like to see what happens.
Can I quickly show you something hilarious that I really wanted to show you someday? When we are already talking about the topic of solar eclipses.
Go.
Just give me a second, I have to find the data first.
When you're ready, just share your screen. Who's got the traffic in the background, by the way?
Not me.
You?
It's not. It's either Angel or Ranty.
There is no traffic around me.
Somebody's got cars going past. Why have you got a snake around your neck?
Why not?
I didn't know you had a pet snake.
Alright guys, I can share my screen again.
Sure.
So, there was the last solar eclipse that I saw, that was in 2015, on the 20th of March. First of all, can you see my screen?
Not yet. Well, maybe.
Alright, so...
30 seconds in delay.
In Wikipedia, so this is the German
Yes.
Wikipedia article about it. And as you can see, a scene from Germany, I'm in Nuremberg, so approximately here. There's the central part of the shadow, the umbra is not visible from this part. So, this is the data for the German energy production. So you can see at every day how many, for example, coal power plants produce how much energy. And when we set this to the date of the solar eclipse, so this is May. Just has to load a little. 24th, 15th, 20th. Was it May or was it March? Ah, it was March, not May. So March. So this is maybe week 12, 14, 15, maybe week 15. No, not entirely. 13. Almost. 12. Right, perfect. So can you guys see this ditch on the 20th of March? Here? The break in the production of solar energy. So yellow is solar energy, right?
Okay.
You see that right about noon there was less solar energy produced than on the morning and on the afternoon. And that's because of the solar eclipse.
Yeah, but this is just a graph, though. What does this really show?
It shows that during the solar eclipse there was less solar energy produced. As you say, we were not in the umbra. So by definition, we were
There was a
kind still
brownout
got
of
less.
the amount of solar getting to the Earth.
Well, I think...
Exactly, and the reason is that we didn't see the entire disk of the sun as seen from our vantage point, because some of it was blocked by the moon. I actually saw this partial solar eclipse live, and you didn't see that it was darker at all, but because we still saw like 85% of the sun. But at least our energy grid saw that something was happening.
Well, respectfully though, Alex,
You can compare it to all other graphs.
Sure, but would you...
There's never this ditch here happening.
Yeah, but Alex, would you agree though that this is literally a graph? Doesn't really prove anything. It's just a graph. It could have been manipulated.
Yeah, well, it's supposed
actually,
to
no, I
represent
think-
data set.
I think you can actually take a look at... this is an identical one. This was measured in Dresden, as you can see. If you want to find the sources, you can find the sources. For example, this is from Austria. Still the same graph, right about 10 or 11 a.m. It ditched in the solar energy output. And you will find that everywhere. So I'm quite sure that this is not faked.
Well,
Because there were some concerns that the solar eclipse could possibly destabilize our energy grid because of this ditch that will happen in solar output. So again, this one. So Stellarium should be ready. Oh,
Hey,
yes.
on that same graph, can you tell which days are overcast and rainy?
Yes, you can. For example, let's just go to 2017 because the model cells we've installed has increased since then. So for example, this is, oh, not at March, I want to go to August. So this one here seems to be more rainy than this one because on this day we produce, actually there's a better way. I really love this website. Ooh. So let's go for the 17th of August. Let's go for the 3rd. So as you can see, 2 days ago, almost no solar input. The day before, oh, massive wind, much more solar input. I mean, it was 11% on the 4th. Oh, this is the 4th, so yesterday. Yeah, it's compared to these 2 days. So the 2nd of August, 0.1% of our energy was produced using solar energy, and 1 day after that, only 9%. So as you see, this varies massively from day to day, not August, July.
Oh, it actually also shows how much juggling the electrical grid has to do on an ongoing basis.
Quite clearly, and on this part here, this is renewables versus non-renewables. So you can, this is actually quite a nice demonstration of how much the grid should adapt towards the input of renewable energy. Cool, isn't it?
Yeah, but it's not.
So,
Would you agree or disagree, Ranty, that that's not persuasive because it's a graph from third party information that may or may not be true? We can't validate whether that's true or not.
Oh, well, you are right. We don't, at this point, know the source. However, it does look pretty honest.
Yeah, it looks honest, yeah, but it is just a graph from a third party source. Our governments
So,
tell us anything they want.
I'm now in Stellarium, okay? So I've set the location to Blackpool, Britain. It's the
Well-
longitude and latitude, so it's 53 degrees 49 north and 3 degrees 3 minutes west. Is that roughly all right?
Alex, see if it's right. See if thingy's there. Rivington in Britain. RIV.
Really? Probably not. Probably not.
Try it though, because it's got a big TV mast, so it should be. RIVIN
Yes.
Rivington.
Rivington. No, doesn't seem to be there.
All right, yeah, go with Blackpool then.
All right. So Blackpool, okay? So we now have to set the date. So this is August the 20th. And let's go a little bit back. 19. So what I'm going to do now is just remove the atmosphere. See the stars. There's north. There is west, I think. Clock, 9 o'clock. So is this the right date? It was the 21st, wasn't it? Yes, that's much better. So right. So 1750. Let's go 1 hour more back. Okay. So here we have the moon. Here we have regulars, which we obviously won't be able to see. And let's go with a 1 minute. Let's change it every minute. So the moon slowly gets closer to the sun. Okay.
Yeah, it's going to be as we get to the horizon. It's not doing it, is it, Alex? Oh no, maybe it is.
Sure, it's doing it.
It is doing it. It is doing it.
Now it's. Ah, wait, I can zoom in. Oh, that was too much. So here we have the moon. Here we have the sun. Let's go further.
Now, the interesting thing is this going to be one of those moons that's invisible on the approach? You can't see it.
We won't be able to by definition, the sun is not lighting the side that is going towards us. We will see. We will not be able to see the moon itself.
Yeah, but it
So
should
as
be.
you can see, the moon reaches the sun. This is really close.
Yeah, you just happen to have some kind of building in the way there. If you could change your
There's a
position.
possibility to remove.
That's why I've got to go on a hill.
Yes, this is better. Right, so what I just did is just remove the background picture that was there. As you see, now it indeed touches the sun.
Yeah.
It's just a little bit though.
Yeah, that's exactly
So
what
you're-
I'm expecting to see.
So this is more or less what you should see directly during sundown.
So basically, if we don't get that tip of the moon, like eclipsing the sun there, and I should see it if it's a relatively clear night, because the reality is it's likely to be a reasonable day because it's still the back end of summer. So unless it's horrible weather, and in which case if it's horrible weather and it's a nil event, so it's a null event, we don't get to find out either way. But there may be other people that are in England that do get a gap in the weather.
I mean, what you could do is ask somebody who's further west, maybe in Ireland or so. That would be perfect.
Well, further south, you'd see more.
Further south.
Yeah,
possibly, I don't know.
down towards Cornwall, Devon and
Shall
Cornwall
we go
way.
for
I tell you who would be
what's the
ideal.
biggest-
I tell you who would be ideal.
Well, I will check it out.
It would be Karen from Sun and Moon Group. She's like right down in Exeter way or somewhere like that. So she's down in southeast England, and that's
Exeter? EXTER?
EX. Yeah,
Exeter.
EX.
Exeter.
EX.
EXETER.
Correct. Exeter, Britain. That's where Karen is in Sun and Moon Group.
Okay, so let's set the date again. The time. Oh. That's it. Date and time, what the heck? Ah, no, here we go. So let's go 1 hour back. And remove again. Zoom in. Okay, and then let it run slowly. It's quite annoying. You guys are really close to the edge of the part where
Say again.
So let's see. There's somewhere there's a oh yeah. So, I have an idea.
Yeah, but what you're saying is what you're proving is that on your guys.
Yes, azimuth, that is much better. So as you can see, yeah, it happened direct at sundown.
So remove the background again.
So as you can see, this is the plus minus 0 degrees line. So this is per definition the equator. And as you can see.
And this is from Exeter.
This is seen from Exeter, yeah. See, Exeter.
So basically, Karen
You need to go down there and visit her.
on the eclipse night. I think I might actually do that because it's not that far away. It's about a 4-hour drive, but it might be worth it if it's a better view. If I've got a better chance of a view, because if Ranty stays up here and I go down there, that's 2 lines of sight that we can cover.
The you go west, the better.
Let's just.
West is more important than south.
Or south. South is.
Maybe, do you maybe have the possibility to take a ferry or something towards the Isle of Man and climb up a mountain there?
Yeah, that's doable.
That would be maybe perfect.
What date's the eclipse on?
The 21st.
What?
The eclipse is on the 21st.
Yeah.
I'm just checking.
2017, 8, 21st.
I was just checking my my availability and what I'm doing on that day.
So, can I stop sharing, or do you want to see something else?
No, that's good because you're asserting the position. That's exactly what we wanted to do, assert the position, because if your model predicts, and that's what we should see, some element of the eclipse, then I'll capture it if I get good enough weather conditions, and I will jump sides, because this for me is one of those rare occasions where you get an observation where it's that contrasting that it can't possibly be explained in any other way. And you've said yourself that you'll accept that the heliocentric model cannot be right if we get the observations and there is no evidence of the eclipse. I agree. The stakes are high in this, in terms of the ability to contrast against the two models is significant. It's prominent in this occasion. Just do it from Ramsey in Isle of Wight. Sorry, Isle of Man, and see, does it make that much of a difference? Because I don't think it would, Alex.
What, from the Isle of Man?
Yeah, as I said, the further you go to the west, the better.
Alex, just
you would be out of the industrial zone in
Alex,
Blackpool.
Just go to the
Yes.
set the destination thing that you've done, like you've got it for Exeter now. Set it to Ramsey in Isle of Man. RAM.
I can find it. How's it called? Ramsey?
RAMS.
No, it doesn't find. No.
Try.
Isn't there a big city in Douglas?
Yeah, try Douglas.
Yes.
Let's see what difference
Got
it
it.
shows. Because it might be.
Obviously.
Ranty, it might be worth getting a ferry over to Isle of Man if just for that weekend. Because the ferries over to the Isle of Man are not going to be expensive. One car ferry.
Actually, Isle of Man seems to be worse. Well, worse than Exeter.
So it seems to be
Yes,
worse, and
worse than Exeter.
that's because you need to go south.
So wait. Just give me a second. It looks like, as seen from Isle of Man, and the sun touches the moon is a little earlier. So yeah, you might be able to see it at 8 p.m. Standard Time. So yeah, that's what you would see from Douglas.
Why should I pay out money to go somewhere when they're going to come back with an argument a couple of days later saying that, oh well, actually we were wrong, and actually we could, you went all that way to do all this and you spent all this money going there, but we were wrong, and actually
how much money would that be to go over to
what time?
Probably 100.
And effort and staying over in L. Right, let's say 200 quid.
Let's just check it now. So we'll look.
Okay, that's much. Just for your information, that's much for the strategy balloon that failed half a month ago. So,
right. Okay. So what I'm saying is that you're asking people to go out and spend £200, and then when they produce evidence that shows something that's contrary to what you believe in, you'll find a way to discredit it, even though you've asked them to go and do this. We had the same with Mick West. Mick West asked us to go up to the Blackpool Tower and take an observation from there.
No, hang on. Alex's position is.
It came back. Oh no, we can't see it.
Hang on. Alex's position is that if we don't get that evidence, then it means that parallax is prominent, and therefore the sun and the moon are close, and he'll denounce the heliocentric model. So he's not going to do what you just suggested. The people that will do what you've just suggested are the people like, let me think, Sly Sparkane, Red's Rhetoric, Sean Hufford, Hillel Finder will do that. Because these are people that don't have the connection to the evidence that you and I and Alex now has. But anybody that's directly connected to this should, if they're being honest with themselves, accept that the parallax will be the moon and the sun will be completely moved on the flat Earth model. So we won't even see the evidence of this parallax. Sorry, the evidence of this eclipse. But if we come back with evidence of the eclipse, that means that the sun and the moon have to be far away. They have to be the way they're maybe not exactly the way they're saying, but it to me that's a flat Earth killer in terms of a local sun. It doesn't mean that the Earth's not flat, but it means that it does mean that the sun's not as far. It does mean that the sun is not as close as what we think it is, the 300-mile thing, because their own model is predicting what should happen. Now, my prediction is that we will see absolutely no eclipse whatsoever. Because the sun.
If you get another two ballers to come on the channel and say to you that if I go to the Isle of Man and film it from the Isle of Man, I will do it.
Right, Alex, in that case...
2 more ballers that do that.
Alex, in that case, I'll pass it to you.
Right. So just give me a sec. Just try to find someone.
But the good thing is, the good thing is, I believe when you go on the ferry, because you can go from Heysham Docks, which is only around the corner for us. But if we go on the ferry, don't they charge you for the car? They don't charge you for the people.
I'm not sure. I've never actually been to the Isle of Man.
Neither have I. But if we go to the Isle of Man in the car and they only charge us per car rather than per person, then that means that 4 of us, 5 of us, 6 of us could go in one vehicle. In fact, we could even take more people with us. If we might be able to get like a minibus kind of thing and take a minibus to and from there, because that would be well worth doing. Although, didn't you say it was worse from the Isle of Man?
Yeah, that's what I mean.
I thought it was, but no. I'm not all over the place. The reason that I thought that it was worse on the Isle of Man was that the part when the moon covers most of the sun, as seen from the vantage point of the Isle of Man, is a little earlier. So I set both locations to the same date, and it looked worse at the position of the Isle of Man. But if we go back a little in time, like 20 minutes or so, then the part that is covered by the moon is bigger than it appears to be from Exeter.
Right, listen, the reason why that's worse from Isle of Man is because we're not just going west, are we? We're going northwest. That would reduce the angle of observation and effectively make it worse. We'd have to go southwest for it to get better.
I mean, you can use Stellarium and find the optimal position. I think that the best position would be as far as possible west in Cornwall. That's the optimum. For Land's End, maybe would be the best idea. But do me a favor and check that up first, because I would have to simulate it first to give you a definite answer.
Well, Jill, could you simulate it first, and then get back to us to an ideal location where we could go from within, say, 200 miles of the location of...
We just need to go down. We need to go down Bristol way, mate. That's all we need to do. Head down towards Bristol, because we need to go south, because otherwise, if we go west, we're actually going north.
You just said the Isle of Man, which is like literally...
Yeah, but listen, I've got Hillel on screen right now in front of everybody. He's saying, Anthony, comparing me to Sly, Reds and Sean, ? Frankly, thank you. What an honour. I don't know why that's an honour. It was But then he said, but seriously, I'm with Geo on this one when it comes to the evidence, smiley face. So I've said, you're on. You will denounce the heliocentric ball model if we fail to get the evidence expected as per your model. And he's now responding, or he was. He's stopped writing now because he's probably realised that I'm quoting him online. So come on, Hillel, will you denounce the ball if we fail to get this evidence that Alex is showing that we should get? Because if we fail to get it, it means that the sun and the moon must be close and the parallax has passed the moon from our position. But if we do get the evidence, I'll jump ship. I will say that sun and the moon are as far away as what they say, because that makes a big difference on this. There's not many observations that we can do where we get this disparity between the two. So come on, Hillel, will you denounce the heliocentric ball model if we fail to get the evidence expected as per your model? Because you say that you're with Geo on this one when it comes to the evidence. Well, if you are really with Geo, that means Geo and yourself are putting your views on the line, because you obviously both realise and agree with me that it's that the disparity in the evidence is that much that it can't go both ways. You guys are predicting that it should have an eclipse evidence. He's typing. Let's see what he comes up with.
I'll say yes.
I hope so. He'll say yes because he probably follows you like a sheep.
Actually, no. He'll say yes because he understands the model behind it and knows that it's going to happen. Right. So
now we've got Alex, and we've got Hillel saying the heliocentric ? Sure. Round Earth. Sorry, no. That's a whole different ball game. Ooh, that he's changing the goalposts. Hang on. This is not. Hang on, Hillel. All right, Hillel. I'm gonna invite you to this call. Let's get you on this chat so we can hear your views. Let's get him on.
Before you take him in, I would suggest you go to Holyhead.
I could get to Holyhead, yeah.
Yeah, because that's more or less as far west as the Isle of Man, but it's about, I don't know, maybe 200 kilometers further south.
Add people to this call. Where are you, Hillel? Where are you?
I've got him in my list if you want.
No, it's all right. I'm adding him. Let's hear his words, because if we can get 2 ballers to accept that we should see this evidence from the UK, Let's see what he'll concede if we do it. Because I'll concede that the sun and the moon the sun at least has to be far away because of the parallax. Let's see if he gets to it.
Well, how about these guys challenge us where to go and where to film from, and we go and do it?
Well, he's saying Holyhead, isn't he?
Isle of Man, and it's gone back and forth. But I'd like some kind of clarity.
Alex, if you want to demonstrate it from Holyhead as an alternative.
Yeah, just give me a date or two to find the optimal position for you, okay? I will send you the location then.
Well, if you did Holyhead now and compare it and contrast it to the ones that we've seen, I mean, we're not going to go much further away than Holyhead. I mean, that's a 2-hour drive.
Sure. But first I have to find the coordinates for Holyhead. Because I just checked it's not in Stellarium.
Oh, Anglesey. You just put Anglesey in Stellarium and that'll give it.
Let me just find Holyhead. So Holyhead coordinates.
Because there's another good potential place called Portmadog, which is called Porthmadog. It's written Porthmadog. That would be another place that you could check it. That's down the west coast.
Let me do Holyhead, okay? Because I would actually really put this on my other computer because this one here is really fast. So this. Oh, this is in seconds. I hate it. What did you say was the name of the city?
Either Porthmadog, or Anglesey.
Let's do it differently. Here we go.
You want to share your screen so we can see it?
Wait, 1832 north and 4 degrees 3758.
Alex, can you check and see if Slice Barkane's on? Because I'd like to know what his view is.
Just let me put in the numbers, okay, so I can simulate Holyhead.
So,
Okay, 1832, okay, I'm now in Holyhead. I will share my screen again so you can see it. Can you see it?
no, you're not sharing your screen.
Okay, maybe take some time. Now? To see my screen now. Can you see it?
Yeah, we see your screen.
You can see it.
Yeah, yeah.
Okay, so again, I've looked up the position for Holyhead, so when I plug in Holyhead into Wikipedia, I plug coordinates. And in the DMS system, it's 531832 for 3758. Shit. Did my Skype just fuck up? No, it's alright. You still hear me, right?
Yeah, yeah.
Yeah, my Skype just closed itself. Okay, going back to Stellarium. So let's go for, as you see, it's the same coordinates, 54, 13, 1832, 437, 58. And let's set the date, so we were 20, right? And now let's turn around, find the sun. There seems to be west.
Ranty, do you know anyone with a caravan? We could just take a caravan and just have somewhere to respite while we're there.
I don't actually. I know someone with a barge.
That's no use.
Exactly.
I know someone with a caravan.
I know someone with a tent. You echoing?
No, I don't think so.
I
Maybe.
hear myself repeating. There we go. Right. I don't actually know someone with a camper van.
No, I don't want to camp. I don't know a camper. I want. I'm thinking if we're gonna do this, we'll take a few of us down there. Everyone jump in the Range Rover, tow the caravan because the caravan will tow with the Range Rover, no problem. It won't cost that much money if we can borrow someone's caravan.
Take a look at this. So this is a simulation from Holyhead.
Yeah, go on.
here, you see the plus 0 degree line, that's the horizon.
Yeah, go on.
But I'm not sure if it's better than Exeter.
Just pull it.
This is what it should be like.
That's quite a chunk. That's quite a chunk.
Yeah, we'll see that. We should see that.
If you zoom, if you can guess, you should be able to see it.
I agree. We should be able to.
Exeter is still better.
Right. So
If you go back to Exeter.
yeah, but Exeter is about 4 hours away, whereas Holyhead's about 2.
Yeah. This in comparison with the Exeter, there is a difference, but I think you should see it from all positions.
It is minimal.
So it's
Yeah. I
It's-
don't fancy travelling all the way down to Exeter when I can do it from local for that difference.
So what about Hillen? Is he joining?
No, he's bought.
Have you done this from America? This
No, don't do it.
Yeah, sure.
Don't do it from
from where the primary target is.
Yeah, but it's going to show you a total eclipse, Ranter. You know what it's going to show you.
Yeah, I know, but I'd like to know.
I'm just going to go for Oklahoma. Oh, if it's in the totality zone, but it should be some.
I'd like to know just outside the totality zone, the apparent totality zone.
So this is the south descent. And the follows. Now. Yes. So at the same time, this is what it should look like from Oklahoma City. Let's just go in time a little. Oh yes. Yeah, it's not that perfect anyway. Nice. But oh yeah, it's getting much better. So oh yeah. Seems to be in the totality zone at least almost. Yeah, almost. So that's even the maximum the eclipse has seen from Oklahoma City. Cool, isn't it?
Yeah, it is cool.
Okay, so if we have someone from Oklahoma City that shows that, then that matches up to which model?
Well, it would match the heliocentric model, but it probably would arguably match the flat Earth model as well, because proximity of the sun and the moon on the flat Earth model is a big debate because we don't know how far away it is. But we're at the best position because we can get it at the extreme before it.
Get a different result when you were looking at it from different positions, even from the United States, right?
Yeah.
Because we have at least 3 or 4 people available in the United States that we could ask.
I think that we're in the best position to be able to negate whether or not the sun and the moon are far away, because we are on the edge of it and we should be able to capture it according to their model. Alex has said that he'll accept that the heliocentric model is wrong. Hillel's bottled it, but I think that if Alex is right, Hillel should stand by you by this. You predicted Hillel's cause wrong, and Hillel's not done that. Let's just see what Hillel did actually say. Sorry, Anthony, I'm not in a chance to chat live right now. Monday, okay? Yeah, Monday's fine, Hillel. Heliocentric, ? Sure. Round Earth, ? Sorry, no, that's a whole different ball game. Yeah, heliocentricity is the issue, really, because it's whether the sun and the moon are far away as what they can. I'm not saying that you have to concede that the Earth's a ball, but or not a ball, but I am saying...
You have to, because
No,
there's a difference when you look at the position of the sun.
hang on. I'm only saying that the sun and the moon are not 93 million miles away.
Practically, it's practicable. I mean, the difference between the ball and the sphere is like 40 kilometers on the size of it, 12,000 kilometers here. So it's practically negated.
The point I'm making, Alex, is that the sun and the sun is not 93 million miles away on the flat Earth model, whatever that model shall be. And if we cannot get this wrong in terms of the evidence, so long as we can capture the evidence and the weather's reasonable enough, then that's enough. If we capture evidence of the eclipse from here, that means that the sun and the moon must be far away. If we don't capture it and we get a full sun, then they can't be that far away. They've parallaxed past each other, and the flat Earth model's on, but the heliocentric model's off. Alex has agreed on the distances. But does it go further than that? You were suggesting that it goes further, Alex. Does it go further than that?
Can you repeat the question I just had?
Does it go further? I mean, my position is that if the sun and the moon show evidence of the eclipse from England, it means that parallax is consistent with the heliocentric model. But if the sun and the moon, if the sun is shown completely full for the duration of the apparent eclipse, according to your model, because we know what time it's going to happen, then that means that the sun and the moon are not as far away as what we're told, because we should not be seeing a full sun. But the question is, does it go beyond the distance of the sun in terms of what that proves? Because does it prove? I mean, I'm critiquing Hillel's comments. He says heliocentric, sure. Round Earth, sorry, no. That's a whole different ball game. Heliocentricity may be out the window, but does that mean that it's not a ball? No, it doesn't mean it's not a ball. I'll give him that. Or does it?
Actually, it does. It does. You can calculate you can find out the shape of the planet using the solar eclipses, but that's quite hard because what you would need to do is you have to look and measure the exact angle in which the moon is passing the sun. You can use it to derive the shape of the planet.
I don't think you can tell the shape of the planet based on this, but I do think that we can distinguish the distance from the... But you agree, though, Alex, that we can distinguish the distance from the sun. If the sun is as far away as they say, then the parallax is going to be prominent it's going to be evidenced in our position. But if the sun's not as far away as they say, then it's not. So if we see a full sun for the whole duration of that time, so what we need to do really is take a ball earther that understands the points, and then as a witness, as a referee, to make sure that we're doing it correctly ourselves. But basically, all we got to do is follow the sun set into the horizon on that day, zoom in as much as we can, and see, do we see any evidence of that eclipse at all? That's all we've got to do. So we'll have numerous cameras on it at different focal lengths, at different levels of filtration, and in theory, we should be able to at least... Well, we'll all get it. We should all get that same sun. The issue is, do we get the sun with any eclipse evidence on it at all? Because if we don't get it, then the parallax issue is not proven, and it doesn't support heliocentricity. This is a really good observation for anybody in England. I think I might invite Antonio, actually, because Antonio will be interested in this. I'm sure Antonio will want to join this, because he's been tracking the sun for ages.
I don't see why he isn't out there on his...
He's a renegade, Antonio. Antonio...
with his whiteboard, making people sign up for it already.
He's a renegade, isn't he? He does what he wants. He does what he wants. So let's bring Skype back up and let's go back to that chat. There we go.
Anthony, is it alright if I mirror this hangout on my channel?
Yeah.
At least the part where I'm in the hangout.
Sure. So,
okay, super.
I still expect you to stand by your word, though.
Sure. I mean, I do the same with you. That's why I'm copying it. So we both have evidence that the other guy has said what he has said.
Yeah, I'm fine with that. I will accept that the sun is 93 million miles away if we see evidence of parallax. Sorry, if we see evidence of eclipse, because your model tells me that we should. But and the reason why I say that is because we can't have it both ways. This is one of those few examples where we get it, where it is far enough away for us to distinguish between the two models, black and white. If the model says, happy days, there's going to be an eclipse, and then we get the evidence that supports it, the sun has to be 93. Well, it has to be far away. I will concede that the sun is 93 million miles away, because this is probably the best.
Los Angeles, what do I see?
You will see an almost full eclipse.
Download Stellarium and take a look at it.
Okay.
Oh, that's horrible, Alex. Come on, show him.
Okay. Let's go. Right.
It's not that easy to do if you've never used Stellarium before.
Actually, it is quite easy. All you have to do is set the time and date and location.
Angel, you're going to see pretty much a full eclipse. On the heliocentric model, anyway.
Can you see my
Well,
screen?
I want to be able to compare what I'm supposed to see to what I do see. I'll be able to say yes. Huh?
No, we
Can I
don't.
see your screen? Hang on, let me get over to YouTube.
Not yet. No.
No, I can't.
Not YouTube. Skype.
No, Angel's sharing his screen. Angel, do you want to knock your screen off share on Skype?
On Skype, yeah, I can turn off my monitor.
Yeah, because then Alex can share his desktop.
Okay.
Go on, Alex.
Oh, shit. So now you should be able to see it.
Yeah.
Hopefully.
Yeah, they'll be see it. It's coming through.
I actually see a black screen.
Yeah, hang on, it's coming through. Hang on, give him a sec.
Maybe it takes some time to load, that's all.
Yeah, now we see it.
Yeah, I got it.
What did you say, Los Angeles?
I got it. Yeah, Los Angeles.
Los Angeles, United States. Alright. So let's go for the 21st of August. 21st. Let's find the sun first. There it is. What I'm going to do is, first of all, switch off the ground, activate the grid. Hero is your home base, alright, so in this case it's this line. Okay, so we have the moon here, the sun here. I'll just switch out the atmosphere so it's a little bit clearer. Here's the moon, here's the sun. And then, ooh, maybe hour-wise fast. Just have to find out whether it's later in the day or earlier.
It's about dinner time, isn't it? 1 o'clock, I think.
Yeah, well, I mean, you stuff, no. But it looks quite close. Yeah, you're a few hours earlier than we are, so it's, I don't know.
What's the time difference between British summertime, Angel?
I'm -8.
Right, so if it's 9 o'clock at night, 8 o'clock at night for us.
8, so it's 9 hours.
Yeah, so it's going to be about midday, isn't it?
Okay.
Here we go. Are we?
It's a Monday, so I should have no problem walking outside at midday.
Was earlier than I expected. Okay. Oh. Yeah, you get massive coverage.
Yeah. You should get almost complete.
So, yeah, that starts.
Now, I actually think that in the real world, you're not going to get it shown like this. I think it's going to go the opposite way around to you. It'll do the same amount, but it'll be, instead of arriving from the top, I think it's going to arrive from the bottom. But don't quote me on that. I'm applying what Antonio predicted.
You seem to get about 75, 6 to 75, and something like that.
See, now that Angel, can you see how when I was saying before that we're 3,500 miles from you, but the moon's supposed to be 240,000 miles away from us? That level of proximity to us is minimal. So even though we're thousands of miles away from you, that represents not a lot of difference between the.
I
As
agree.
you can see, it's getting less. Yeah. So it seems to be about 11 UTC, the maximum coverage of the moon. A little earlier than that.
Alright, so mid-afternoon.
About 10 UTC. So. -8. I'm not sure if this is UTC. Maybe this is local time? Yeah, this is probably local time, not UTC. So 10:30 your time maybe.
Okay.
Yeah, here currently UTC -7. So yes. About 10:30 you at UTC -7.
So the other thing is, Angel, is when you're watching this live, if you think on, we'll be doing the same observation and seeing the same sun and supposed to be the same moon, and we'll be watching the same thing but from a different angle, and we'll be seeing a fraction of it. But the parallax can't exist on a flat Earth model the parallax will have been and gone. Whereas it only works on the heliocentric model. It doesn't work on the flat Earth because the parallax has been and gone. The moon's already fucked off somewhere else. And Alex agrees. Hillel Finder also agrees. I need a caravan. I need to borrow somebody's caravan for that day. What are you doing, Alex?
For that day?
No. Right now on No, on that screen, what are you doing there? Because you seem to be doing some minute precision.
No, it's doing that in time.
All right, well, we're losing you.
The exact time, yeah.
All
It's
right.
running at real time.
Oh, I get it. It's running at real time.
Okay.
I'll just move my thing over there so that other people can see that. There we go.
Well, as far as the real-time thing, I actually have some place to be by 1400 hours, which is in 22 or 12 minutes, or close to that. So I'll be back in a few minutes if you guys want to keep this thing running. But
Sure.
I'm going to take off for about 15 minutes.
Yeah, that's cool, man. You go and do what you got to do.
All right, I'll be back.
All right. Although, I hope Angel's going to put him on mute.
Other positions to calculate. If you already
Angel,
did that.
do us a favour, Angel, if you hear me. Just stick yourself on mute. Sorry, Alex, say that again.
If we're already modeling it, any other locations, maybe Portland?
No, not really, because there's only Alex.
Totality zone.
There's
Yes, look at that.
Portland.
So this is Portland, Oregon, the same time. Skip ahead 1 minute. Already totality. See that? Almost.
Just a question for flat truth in the chat. Alex, give me a sec. A question for flat truth in the chat. Do you agree, flat truth, that the parallax issue, if we see evidence of the eclipse in England, that supports heliocentricity? Absolutely. And it doesn't support that the sun is close. And alternatively, if we fail to get evidence of the eclipse in the UK, providing we can see the sun, that really proves that the moon has already parallaxed past the front of the sun, and the moon is already to our left. So the sun's already gone past on the flat Earth model, and that cannot happen if the sun is 93 million miles away. Karen says, no, it doesn't prove it. I think there are things at play that we don't know about yet, or that we do know but not exactly sure how it works. Yeah, but Karen, the official narrative is that it's the moon causing the eclipse on the sun, and if it is the moon, then we can test that in the UK by making sure that we either do get the evidence or fail to get the evidence. So this will either be, like George Airy and his failure, George Airy's failure. This will be like Riley's failure as well. We failed to see the evidence of the eclipse when testing it from the UK. Flat Truth says we need to make sure it's the moon that's going to cause it. Well, according to the heliocentric model, it is the moon. Now, whether it is the moon or not is not really an issue. If it is the moon, then we should see it according to the parallax issue. So it would probably support it being the moon if we got the evidence. But if we fail to get the evidence, then it may not be the moon that's causing it. I would agree. It could be something else causing it. I mean, everybody's accepting that it is the moon that's causing it, but I'm not happy that it is the moon. I think something else could be causing it. I still think the moon causes a solar eclipse. Possibly, Karen. I will be watching for proof otherwise, though. The other thing to bear in mind is not only look at the eclipse that's happening right before our eyes, look around you. Look for where else the moon may be along that rises in the east, sets in the west. Because the moon may well be visible elsewhere. And we're all looking over here, but we're not looking over there, and that's where the moon is. So just because the moon is supposed to be where they tell us it is, doesn't mean it actually is the moon. We may get sightings of the moon elsewhere along the plane, along the path of the moon. So when the moon rises in the east and sets in the west, if it's not the moon that's causing it, or it is the moon that's causing it, but we just can't see it, then there should be no other sightings of the moon anywhere. But being in England, we should be able to see, hopefully, any evidence of the moon elsewhere, because I don't like the idea that this moon is invisible to us when it's approaching, because it should be getting reflected light from the Earth. I don't accept that it's not getting it if we get reflected light from the moon. I don't think they can have it both ways.
It is getting reflected light from the Earth, but it's still in broad daylight. I mean, you can't see stars in broad daylight, so why do you expect the moon to be visible, even when it's lit by reflections from the Earth?
Because the stars are millions of light years, millions of miles away, or light years away, but the moon's only 240,000.
Yeah, but
No, it's an.
right.
Alex, not
More light per area.
Alex, knock your screen off, because you're breaking up while you're, because you're screen sharing as well. What was I saying then? No, I don't agree, Alex. I think that if the sun is providing light to the Earth and then bouncing off the Earth and hitting the moon, we should see the underside of the moon. I don't accept that it should be black.
Yeah, it isn't black, but it's still overlit by the sun.
Ranty, what?
As are the stars. The stars are actually brighter than the moon when you just take a look at how much energy they radiate to us relative to their parent size.
Ran-
When we can't see some of, at least the brightest ones, when we can't see them, then we won't be able to see the moon in daylight. And the thing is, we can actually observe stars in broad daylight with big telescopes, as we can do with the planets. When you have a big enough telescope, you might be able to spot at least Jupiter and Saturn in broad daylight.
Ranty, what?
With the naked eye, you have no chance. You need something that amplifies the amount of that you gain.
Ranty, what are your views?
On what?
Everything that you've seen so far, do you agree that the parallax issue only ever supports the ball Earth model if we see it? If we don't see it, it doesn't support the ball Earth model at all?
I agree with that.
I'm looking forward to this, because it's one of the, like I say, I mean, I keep saying it over and over again, it's one of the few examples where we can see something that we can categorically say that it's either one or the other, but it can't be both. Most observations, bendy light, whatever, you can argue both ways, and credibly argue both ways in most instances. But this one's definitely not one of them. This is right on the extreme edge of the cusp of everything. For me, it's like, ooh, this is potentially a ball breaker in terms of one of us. If we see the evidence of the eclipse, then that means that the sun has to be far away. If we don't see evidence of the eclipse, it means that it's already parallaxed, and we're not seeing it. We are seeing it locally, and parallax has meant that we've missed it completely. If we could even see it at all, it might be the case that we might have seen the eclipse like an hour and a half earlier, but I don't think so. Maybe not. I don't know, because we don't know we don't have a flat model to be able to predict it. But we do have a ball Earth model that can predict it, and if it does what we say, then that is a distant sun. I'm well looking forward to this. I need to find somebody with a caravan though, because I can't be asked going over there and sitting in a car for ages. I want to make a brew. Cool, Alex. Thank you very much for your illustration skills, because you actually come in really handy for once.
Thanks.
No worries. And tell Hillel I expect him to denounce the heliocentric model if we don't get that evidence as well, because he's kind of put his name to it. He doesn't have to admit that the Earth's a flat plane, but he does have to admit that the sun's not as far away as his own model tells him. So that's two of his. And I would expect Slice Barcane to concede that point as well if this evidence doesn't materialise the way it's predicted. So basically, I've achieved what I wanted to achieve tonight. I've had somebody model it on a heliocentric model showing us what we should expect to see. And I was right. We should see some part of the eclipse. Maybe not a lot of it, but certainly some of it. And we should be able to record that, because we easily get the sun setting on sunsets all the time. The interesting thing's going to be, thinking about it, is the band of...
One question.
Yeah.
What about Slice McCain? Why do you want him to confirm it? Because he's quite close to me, right? And he won't be able to see the eclipse at all. He's in Germany.
Yeah, I know he's in Germany. The reason why I want Slice Barcane to concede that point as well is because he's involved in the eclipse discussion as well. Sun and Moon group have invited him to...
You're
No, not observe, but concede that the sun is either not where they say it is on the heliocentric model, or it is where they say that it is, because there's the proof of it in the eclipse. Because Sly's been invited by Sun and Moon Group to have a hangout with them on Tuesday. Hang on Tuesday night at 9 p.m. British summer time, 10 p.m. German time. Because Sun and Moon have done a video where they've invited critique. Sly's got critique, and I've kind of joined the two together because I have a dialogue with them. I speak to them, and I speak to Sly periodically. And it was like Sly thinks that they're wrong, and they've said, well, if you think we're wrong, come and show us how. So then hopefully I'm going to try and get Sly and Sun and Moon Group to have a hangout where, because really, if it's as the heliocentric model according to Kara is so intuitive. It's very intuitive, and that's the phrase that she bandies about. Yet nobody seems to have a consensus. You've got Jeren saying it might happen on the heliocentric model. You've got Antonio saying it's a ball breaker. You've got other people that are saying it. Well, the Sun and Moon Group say it's not right. It's impossible. I don't know whether it's possible or not. If my gut feeling tells me it shouldn't be. But I think this evidence from the UK observing the eclipse is the strongest yet, because you can't have it both ways on it. If the evidence is there, it supports heliocentricity. If the evidence is not there, then it doesn't support heliocentricity. And on that basis, I would confidently be able to. I'll put my balls on the line with it. So Sly Sparkane, if you're watching right now, I will agree that this is the way it should be if the evidence is there, and I will say that the sun is 93 million miles away because it matches the model if the evidence matches it. But if the evidence is missing and we see a full sun, then that's not going to be the position. But there is one thing to consider. It's going to be happening just above the horizon. We're going to have that band of refraction in the middle, in between us at some point. And it's whether or not the eclipse overlaps with the band of refraction on the horizon. Because it's conceivable that the sun could start to set and get to the horizon at the same point where the eclipse is now taking place. And we can't see it because of this band of mirage on the horizon. Would you agree, Alex?
Yes.
So that's a problem that we will foresee. We'll have to foresee, and the only way out of it is if the humidity is low and the band of refraction is less. I mean, I'll be able to see, and we're going to be looking out over the sea as well.
Actually, if I remember correctly, you should see the eclipse 5 degrees over the horizon, so that's much more than the band of refraction that you might have.
Do you want to just double check what the degrees was above the horizon? I know you said it was more.
You could see a part of the eclipse at 5 degrees over the horizon, so yeah.
Right, so the band of refraction shouldn't even get in the way then, right?
Yes. Maybe in the last seconds when you really had sundown, but before that, no, not really.
That's cool. Happy days. Alex, you've been a star tonight, to be honest.
Alright.
You can stay on for a bit if you want. I'm going to invite Good Times for All in because he's joined in the chat. So, Zach, if you're about and you can speak, I'll add you to the Skype call. Alex, you want to stay or are you going to get going?
I think I'm going to get going.
All right, well,
Do you have any questions left?
no, I'm good. Ranty,
Maybe somebody in the chat?
any questions in the chat for a ball earther? Karen, have you got anything to ask Alex? Because it's not very often we get ball earthers in that are actually polite and friendly. Usually ball earthers sit in chat with no wrenches, but Alex is in. So, Zach, where are you? Good Times for All. I'll add Zach to the call, see if he wants to join us. I don't know how good his mic is, but we'll try anyway. But if there's any questions in chat for a ball earther, we may as well ask them now. Karen, if you want to ask something, ask now, because Alex can get going otherwise. And this is probably...
Let's just give them 30 seconds or so because of the delay.
Yeah. And they might be typing as well, so we'll give them a minute. But I actually think that this is one of the few examples where this is actually going to be one of the best hangouts, because we're preempting what should happen evidentially, and then we're going to test ourselves to see what we actually do get, because I honestly don't know what we'll get. I know what we should get, but I don't know what we'll actually get. So I'm really looking forward to it. Give me 15 minutes in the car at a minute. So Zach's on his way in 15 minutes. And then Angel will be back because wherever he's gone doing his thing. So we'll give Alex another 30 seconds. If there's not an in from the chat, we will wrap it up from Alex's point of view, and you can be released back into the German domain. Out of interest, what are you doing tonight? Are you are you doing anything in? There we go. Ask him why we don't see the moon approach the sun. Yeah, why is that? Why don't we see the moon approach the sun? Because we should see it approaching the sun.
Because when the sun, when the moon is close to the sun, first of all, first of all, you can only see the part of the moon that is lit by the sun in broad daylight, and therefore in daylight you usually see you only see the moon when it's the furthest possible away from the sun. So as you know, you can see the moon at daylight, but not when it's close, because there is no part of the moon that is directly lit by the sun when it's close to the sun.
But why don't we see a ring around the outside of the outside of the moon, showing that the sun is lighting up the opposite side?
Oh, you will. When you're in the totality zone, you will see the outer layer of the atmosphere of the sun called the corona.
Correct, but what?
But that's only, the corona is really dim, so you only see it when you can't see the rest of the sun, because the rest of the sun is much brighter.
I don't agree that the sun is only lighting up the other side of it, and therefore we're only seeing the dark side of the moon, because I still maintain my position, which is we should see the reflected light from the Earth, because let's be honest, above the clouds, when the sun shines down on the clouds, it's basically white or a shade of grey, but it's generally a light shade of grey. All that light should be shining up against the underside of the moon, and we should see that. There's no reason why we shouldn't see that. I don't accept that we...
It's not that much light as you think. The stars themselves are brighter than the part of the moon that is lit by the Earth. And when you can't see the sun because it's overlit by not the sun, when you can't see the stars because they are overlit by the sun, then you won't be able to see the moon for the same reason.
No, I don't agree. I think that we should still see the sun reflecting its light off the clouds.
You mean the moon?
No, the sun reflecting its light off our clouds on the underside of the moon. We should see that because the sunlight comes into Earth, hits the top of the clouds, it bounces off the top of the clouds, and it lights up the underside of the moon on the approach to the sun. When the moon's approaching the sun, I don't accept that it should be in blackness. I agree with Karen. We should be able to see it. I don't accept that explanation. We should be able to see it. But it's cool. We can disagree without falling out with each other. It's just a difference of opinion. That's all.
I mean, we could calculate it, but I would have to look it up, but it's definitely possible to look at it to find out the value of how bright the moon will be.
Well, you know what my views are on maths proving anything.
Yes. So, then see you guys, I think.
Alex, thank you very much. I appreciate that.
Sure.
And I'll look forward to discussing the evidence with you when it comes to the relevant time.
Me too.
All right. See you soon, pal.
See you.
Right. So Alex has dropped. Ranty, have you got any closing comments?
Not really. No, I'm just listening in at the minute. I'm trying to figure out this program that Geo was on before.
Yeah,
GeoGebra.
Yeah, GeoGebra.
I'm getting there. Yeah, I'm getting there. So hopefully I'll be able to muscle up with him tomorrow evening.
Any questions from chat? Because at the end of the day, I mean, there's I don't know how many people are on right now. Let's just see how many people are watching. My channel. 51 watching. Geo, don't worry about the bandwidth and the audio. You got done everything that we really needed to do, so it's all good. I mean, essentially, I think that we're kind of in the position now where we've got the evidence that we know that we're supposed to be looking for. We know what the heliocentric model tells us. I can only thank Alex, because this is information that I would never have been able to work out myself, and Alex has done it. It's going to be interesting because I'm going to be on the hill, right? So for me, it's going to be... So if you just think of the words of that, the fool on the hill sees the sun going down, and the eyes in his head sees the world spinning round. Are we really seeing the world spinning round? Am I going to be the fool on the hill? Or am I actually going to see the sun doing what we think it's doing, and which is just literally disappearing off into the distance? The evidence will tell us. and it's the absence of evidence. It's going to be like the Antarctic 24-hour sun. Carolyn, the eclipses have been predicted for a millennia, right? How do we know that they are using the moon to predict it? We don't. Carolyn, all they're doing is noticing the patterns. They notice that these patterns happen. Doesn't mean that they know why they're happening, but they notice that the patterns happen. So again, it's the issue is causation. What's causing them? Sometimes it may well be the moon, other times it's not. But I don't accept that this is not... Do you still want to call with microblognism? I think you called him out earlier. No, Gio, I said, give him a shout out. Because I saw in your Skype that he'd told you that I was having a chat about the moon. So I was saying give microblogging a shout out because I saw that he was acknowledging me. So just say thanks. Anthony saw your comment and just gave you a shout out. That's all I was saying. Rod Knocker, did you recently start Twitter? 11 followers. I did, Rod. Last week sometime. I should have put a comment on Twitter before I started. But Rod, if you want to join on Twitter, please be my guest. Let's see. You the big boss on Skype. Yes, sir, that's me. What type of experiments do you plan on doing? I'm not sure who that's aimed at. Yeah, Alex, you did misunderstand. It's fine. Yo, Morky, not speaking to you. But the pattern they follow is Rahu. Didn't most or all of the cultures think it was not the moon? That is what I am trying to figure out. If the moon is responsible for the eclipse or not. I agree, Carolyn. A lot of the people think that it's Rahu, Ketu, or some other form of celestial body. I have considered the possibility that it's Lilith, the black moon, because the moon's going to appear black. But AJC 1844 said that the black moon is on the other side of the zodiac, so it's not in proximity to it, so it can't be the Lilith. It could be some other celestial body. So I agree. We shouldn't rule anything out in terms of what is causing the moon, the eclipse, because I buy into the idea that it might not even be the moon. The moon, because if we can't see that it's the moon, how do we know it is the moon? We identify the moon by the craters, but if we can't see it, how can we possibly identify it as the moon? In the heliocentric model, of course, it's because it's a process of elimination. Flat truth, that was from Zach. I'll take my large level on a ball, sun, water. Any other ideas? Morky, you're not talking to me. Morky, I'm not talking to you. Lilith, Rahu, Ketu, Anthony Riley. I also believe it's a dark celestial body. I agree. I agree. It's a dark celestial body. Balago, Lilith isn't a separate celestial body. Yes, it is. There is no evidence for Rahu existing. Nothing. Yeah. Go and get that first, though.
For downstairs?
Yeah. I'm being summoned to the hot tub. It's 22:06. It's pitch black outside. It's cold.
You're not going to do that live, are you?
No. Not yet. I haven't got it set up properly. There'll come a point where I do it live.
Can you, well, you did do it actually. P-War's got a good video of you.
Yeah. I couldn't quite hear you guys though, but yeah, there's going to come a day where that happens, just so I can piss off the trolls. Carolyn says, watch the video by Phuket Word. He talks about how the Earthshine proves the moon can't be responsible, in his opinion. Can someone link to that video? You can just go to Phuket Word's channel. I agree. The Earthshine proves that the moon can't be responsible. I agree. I've not seen that video, but I agree that Earthshine should light up the backside of the moon. Because if we see the reflection of the moon from the sun, then it makes logical sense that we should see the moon from the reflection of the Earth. It does work both ways for me. There is nor is there evidence that the lights in the sky are planets and stars. The only thing that we can say with any certainty is that the lights in the sky are lights and stars. Just that they are lights and stars. What the stars are is another issue. I think that the stars are some kind of frequency or something, a light manifesting frequency that we can't perceive, or I don't know. The stars don't appear to be they don't seem to be a tangible object for me, because they are psychedelic. They change their shape far too much. There is a video of Rahu, allegedly. Check Subphotonic's channel. See, I don't think Rahu exists the way we see it. I think it's more like a black hole than a black moon. But I don't know what Rahu and Ketu are. I know what they're supposed to be, but the evidence that supports them is hard. It's not persuasive. It's more extreme than persuasive. Lilith, also known as a dark moon, is just a term for the most distant point in the moon's orbit. It's not a physical entity. No, Blago, that's not what Lilith is. You need to look up the ephemeris. Look up what the Lilith is in the ephemeris. Whatever it is, it's a body that they know about and they can document its movements. It's not just a term for the most distant point in the moon's orbit. That's what they're telling you. That is not what it actually is. It's a physical object. They know what it is. They know where it is. They plot its movements. It's not a reflection of its distant point in its orbit. Gravity hills are cool. We've got one of those up in Hilbray, somewhere up in Scotland somewhere. Have you seen it, Ranty?
Where's that?
There's a gravity hill somewhere up in Scotland.
No, I haven't actually seen it, no.
Yeah, you pull up.
I do go to Scotland quite a lot.
You pull up in what looks like a downhill position, and the car starts reversing up the hill. It's
that's a load of bullshit.
No, it's not. It's true.
I've seen the video. No, I've seen it. He puts his glass down, and the tilt of the actual water is the opposite of where he's actually tilted his actual camera.
It's definitely not.
Well, we'll disagree.
Well, we'll go and do it one day. Yeah, I'll do it. Blago site. Hang on.
I just respond to Morky. Thank you, Morky. I actually got a big slap across the face this morning. I had no idea why, but apparently you and Lynn were talking. I don't know what you talked about, but I got a slap. So I'm just putting it out there.
Blago, the citation that you request, if you look up Raphael's Ephemeris 2017 edition or 2016 or 15, Raphael's Ephemeris, that refers to exactly where Lilith is, and in there it tells you what it is. It's a celestial body, and they know what it is, where it is. So your citation is Raphael's 2017 Ephemeris. You can Google that phrase, you'll find it. So there's your citation, Blago. Good times for all. I'm going to see if I notice feeling different when the eclipse happens. No, I don't think we will, unless you're a wolf. Apparently wolves and anybody lunatic feels it. Carolyn says, Blago, in astrology, yeah, Lilith has got different meanings depending on which discipline you're in. Lilith means different things astrologically than what it does astronomically. Astrologically, Lilith is something completely different. Astronomically, it's in the ephemeris. So don't look at it from the astrological point of view. The astrological point of view is a waste of time. Look at it from the astronomical point of view. That's where we're referencing it. Shumi, I've been on that hill. Rahu and Ketu could easily be an energy anomaly in the ether. I agree, it could be. Blago looking, give me a sec. Blago, when you find it, give me a shout back so that I know that you found it and that you at least accept that there is a citation that I gave you that's credible, that references the black moon or Lilith. You should see it referenced on the front cover. We need to consult experts on astrology and Lilith about this. They are out there, in my opinion. Carolyn, if you contact AJC1844, AJAYCEE 1844, he's the one to speak to about Lilith, because he's everywhere. I go there all the time. Astrology is just a religion. Astrology is probably a religion, in my opinion.
Do you actually know where this place is, and that shows the apparent, anti-gravitational stuff that goes on in Scotland?
Yeah, it's in what's it called now? Just type in it's called just type in Gravity Hill, Scotland, and you'll find it. Acacia Crescent Moons. Tell me about the Acacia.
I will go out of my way in October, because I'm going up to Scotland in October. We're booked a week away up there.
Yeah.
And we will make sure we go there, and I'll do a video on that. But I'm absolutely certain that what I saw was when he put his beer glass down, was basically the opposite of what he was trying to say. The water always finds its level.
There you go.
It stays flat.
Electric Bray is what it's called. Just type in Electric Bray at BRAE in Scotland. You'll find it.
Okay.
I agree. It's up there somewhere. I don't know exactly where it is, but it's a phenomena that it's to do with the landscape. Everything's going downhill apart from this one little bit that goes uphill. But in its proximity or in its environment, it appears to be an uphill battle, but it's actually downhill. It's an illusion, and it'll give you a head fuck when you get there, but it is true.
Actually, it's not actually that far away, actually.
No.
It would only take me, 2 hours to get there?
And I need to ask, Acacia Crescent Moons, why are you trolling me with a load of stuff to do with Islam? Is it some kind of religion thing that you have? Because I noticed that you have 0 subs, so I'm assuming that you're a troll. I'm just wondering why the Islamic... Oh, you're giving me all the Islamic chanting, because... What the fuck's religion got to do with anything that we're talking about? It's past and before Strathmar. See, you do have useless bits of information in your ACM. I'll call you ACM. Praise be to Allah. Yeah, what the fuck's all that about? Anyway. I just had an email come in, so let's just see who this is off. That's junk. I can go back.
Let's see when can I get over there. I could go up there in 3 weeks, you know.
Do it. You'll enjoy it. It's a good trip to do because it's just a trip out. But when you get there, it's like you have to be careful, or it's on a bit of a bend. But man, then again, all the locals know about it, so they know that when there's anybody parked up there, they're doing this gravitational thing.
Yeah, and what you need to, if they put a spirit level out there, and
yeah,
I have never seen it done with a spirit level.
The spirit level shows that you go in the way consistent with gravity, because it says that you should be going the way that you're going, but all your senses tell you that you're going the opposite way. There's a coach video. If you find the coach video, a big white coach, and he pulls up and he starts to roll backwards up the hill from the distance he's just come.
Yeah, I've seen it. I call bullshit.
No, seriously, it's true. It's true. It's an illusion. It's an optical illusion caused by the
Oh yeah, it's an optical. Yes, exactly.
Yeah.
So I'm gonna drive 2 hours to go and watch an optical illusion.
Yeah, but when you get there, it'll fuck your head. It's worth going. You'll agree that it's right. It is an optical illusion with the local surroundings.
Interested in facts, my friend.
Well, the fact is, it seems to defy gravity, but the reality is, if you look at it from the opposite side of the lake that it's on, you can see that it isn't perfectly level. It goes the way that it should go, but when you're actually there doing it, it feels as though you're doing it the opposite way around.
Yeah, if I wanted to feel something, I could go on to Blackpool Pleasure Beach and go down the big one, or something like that. I'd get a real thrill out of that.
Yeah.
I don't need to drive all that way to get some kind of optical illusion. You know, if it was like a realistic, you know, it really happened, I would do it. But I'm sent on these wild goose chases. People tell me, oh, go here, go there, do this, do that. And it's all just bullshit.
Look at the sea when you're at the electric bray and it will kill illusion. No, I accept that it is illusion based on the local topography, but I challenge you to go and do it, Ranty, if you're going up in Scotland. Just do it. Take the long journey up there and see.
Yeah, I'd do that, but I would also go in 3 weeks' time. I've got some free time in 3 weeks. I could go and do it then. But if it's just literally to go and feel an illusion, well, what's the point?
Just because it's somewhat...
Convey over a video, is it?
No, but it's just one of those things that you can experience for yourself that's weird. Anyway, let's keep an eye on this actual hangout. I can't remember what it's called, but this hangout is basically the sort of conclusion of today's hangout is that Alex and Hillel Finder, and I'm gonna put Sly Sparkane in that one because if you get 2 ballers that both concede, I think that the real biggest gobshite in this one, and I mean that with affection, Sly, is you. Sly should also concede that if the parallax if the evidence is there for the parallax in the Ball Earth model Happy Days, I'll concede that the sun has to be that far away. But if the evidence is missing, then you 3 motherfuckers have got to concede that the sun must have parallaxed, the moon must have parallaxed past the sun, and therefore the heliocentric model must be wrong because the evidence that you expect to be there will be missing or is missing. So I'm looking forward to this. That's the conclusion, and I guess we'll wrap it up now because essentially I want to go and jump in the hot tub for about half an hour. Ha 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 ha. So thank you all for coming. I think there's 50 people watching, 51 people watching now. Angel.
You should leave it on. You should actually turn your cameras around so we can all watch you in the hot tub.
Back of the house, though, innit? I'm at the front of the house for the thing.
You need new cameras, mate.
I need long wires.
We don't need that, Ranty.
No, we don't need long cameras.
Runty.
Yeah, runty runt runt.
Runty.
I love it that you get called runty runt runt. Runty.
Runty.
Yeah. It's got to be. Sorry, Angel.
We need a wireless camera.
Yeah,
No,
could
we
could
don't,
do that.
Angel.
Runty runt runt. No, isn't that got to be the best nickname ever? Hey, cats, you've just
I actually considered changing my name to that,
runty runt runt. You should have set up a sock account. You should have done. Hey, cat's eyes, you've missed it. We've had Geo Strieber and Hillel Finder, that are both ball earthers. They've come to the table. They've both conceded that if we do the observations of the eclipse from England, they expect on their model to see evidence of the eclipse, and it's not a load, but it's enough for us to be able to detect. And if the evidence is missing, two ball earthers have conceded that they will concede that the sun is not 93 million miles away if that evidence is not there. So we've got two ballers that are putting the balls on the line, and I've also said if the evidence is there, I will concede that the sun must be 93 million miles away, or that kind of distance, because that parallax, we wouldn't get that parallax if the sun and the moon were close. So two ballers are prepared to concede it. I'm prepared to concede it. Basically, balls are on the line here. So you've missed it, cats, and you haven't had to do any modding either. There were really good
We
mods.
still said he's not live. Apparently you're not live.
Who's not live?
You're live.
I am live. I don't think he's talking about me. I don't know. Yeah, I'm definitely live.
I'm positive you're live. I'm watching you.
Yeah, I'm
I
watching.
mean, but he's talking about.
Yeah, we definitely are live.
We are definitely live.
He's not talking about me. So I reckon we can wrap it up.
I took you guys in the conversation with me to the bank.
Oh, did you? Were you putting in or taking money out?
Put money in.
That's always a good thing to do.
And how does it go when you try to get it out, though?
Mine
I do all that electronically.
yeah, mine says goodbye.
Same with everyone, I think. It's like electronic in, electronic out, and then you still skip it at the end of the month.
Yeah. So listen, cat's eyes, Karen B. Spread the word in amongst the ball earthers, because if they all concede to this heliocentric dogma, then they've got to concede that if that evidence isn't present in the observations when we do the observations, they've got to concede the point that the sun cannot be 93 million miles away. They've got to concede that. If the evidence is there, the ball earthers have got to concede that the sun must be far away, because this is proof and evidence of parallax. So it's really a case of pass the word round, let everybody know that parallax is the word. Forget the bird. Everybody's heard about the bird. Forget the bird at Pontchartrain. Let's deal with the parallax on the eclipse.
Where's the videos going? Where's everybody's video? Where should everybody upload their videos, or put them, or at least link somebody to them?
Upload them to YouTube and send Anthony the link.
Yeah, that's what we'll have to do, and we'll have to do a hangout where we collate all the videos that everybody collects, and we'll go through them all. And basically, anybody around the west coast of Europe, like France, Spain, we should all get consistent evidence that supports the parallax of a distant moon at 93 million miles away, or we should get a hole in the evidence that doesn't support the parallax of this sun 93 million miles away. So it's essentially it's a do or die thing, because it's proving the parallax at 93 million miles. It's a really, really good observation, this, and I can't wait for it now.
Get your iPhone out. You know, if you've never uploaded a video before, or you've never taken a video before, get your iPhone out. Record the eclipse, and then put it up to YouTube, and just let somebody else do the maths. You know, I'm not one about all that. There's clever people out there that can do that. Antonio will be good.
That's what I was just about to say. Cat Earth has just
He can spend a lot of time on that sort of stuff.
Cat.
He's got the ability to do it. So if the more people that take video footage and evidence of this, the more we can triangulate everything.
Cat
The
Earth.
best things to know are the time and date that you took it, the time, so that we can
The
track
time
it
is
out.
very important.
Yeah, the
If you
time.
can get your street address address coordinates or GPS coordinates or something to correlate to it, just so we can pinpoint it that much more, or at least your town.
Exactly.
Cat
That's it.
Cat Earth.
Time and GPS.
Cat Earth says, "What, Anthony? What do you think of the past eclipses? Surely this eclipse will happen how they say." Antonio Subarats is the one to ask about that, because the eclipses don't happen the way they say. They happen how they say sometimes in some locations, but they don't get all the eclipse information correct in every location. Some locations are wrong. There's evidences that they predict that the eclipse will happen right to left or up to down, and it goes the opposite way around. So, Kat, speak to Antonio Subarats about the eclipse, the reliability of the evidence in favour of the eclipses, because they don't predict it right. Antonio will support that statement. He says that the eclipses are often wrong, and he actually called this eclipse with me in maybe, when was it now? Beginning of summer, April, Mayish. I was round at Antonio's house, and he said to me, "You need to keep an eye open in September for this North America eclipse." He said, "What they say is going to happen, it's going to happen backwards," and he was actually bang on. So Antonio may get a lot of shit from some people. He may get criticisms left, right, and centre. But on this occasion, Antonio called it with me at the beginning of summer, and he was right. They are calling it the wrong way round, it appears. So, in any event, speak to Antonio about the eclipses, because he'll be able to wrap things up for you on that. They don't get it right. The perception is that they do, but they don't appear to, because there are gaps in it. And I reckon this is going to be a big one, because it's either evidence there or it's not.
But the most important thing is video.
Yeah.
If you're awake and you're there and you see it, get your iPhone out, get your camera out, video it. Time, date, location.
Yo, I gotta go. Guys, ladies, gents.
Hot tub day.
Yeah, hot tub. It's rum and coke night. Saturday night. What else do you do on a Saturday night?
It doesn't matter about the quality, just get the videos recorded, get them put on YouTube.
Yeah.
Time, date, location.
Yeah, I'm going to start beating the drum when we get to that point. I'm going to beat the drum a lot. But listen, guys, I got to go. So if you like the Hangout, give me a thumbs up. If you didn't like the Hangout, give me a thumbs down. Either way, add me on Twitter, because I don't have many subscribers on Twitter. But otherwise, come back again when we see you in the next few days when we got something else to talk about. Peace out, everybody. I'm getting in the hot tub. So, have fun. We'll see you soon. Bye-bye for now. Hola. Bye-bye.